I see the slide, it shares it a little bit awkwardly. The name and so on is not absolutely correct, but that's the idea. That's the title slide. That's day 2. Slides set for day 2. So it says on there, it says MIP780 Maintenance Practice, class day 2. That's what it ought to say. Good morning, Ivy.
Good morning, sir.
How are you?
I'm all right, and you?
I'm fine, thank you. I'm fine. I'm much better than yesterday, because yesterday I still had to prepare for today, and I had a lot of work to do. Oh, you can't believe it. I worked the whole day from 10 to 7 last night on preparing. But now I'm ready. I'm ready for you. I hope you're ready for me.
No, it's just too much. I hope I will.
What's too much? What's too much?
There's so much work.
Oh, yeah, but
There's so
life is
much
a lot of
work.
work. Yeah, life is a lot of work. Good morning, Ashrima Rampersad. Good morning.
Good morning, Prof.
How are you?
Fine, thanks, and you?
I'm fine, thank you. I'm fine, thank you. Morning, Kgalelu. Kgalelu. There's a lot of syllables in that name. Ms. Ratsuhana. Yes, sir. Yes, it is like that. Good morning, Bian.
Morning, Prof. How are you?
I'm fine, thank you. Yourself?
I'm well, thanks. I'm going to try and attend this session for as long as I can, but I might need to run earlier.
Okay. Hello, Werner. Werner said good morning on the chat. Good morning, Tabi Singh.
Good morning, Prof. How are you?
I'm fine, thank you. I'm fine, thank you. I think I must put on the slide, I must put I'm fine, thank you, because I've said it so many times now. And you yourself? Morning, Ruvashan. And now such a lot that comes in. Roger and Cisetsi. Good morning, good morning, good morning. And you know that you are 50 students. It's the biggest class ever for maintenance practice. Morning, Ruvashan. So there's now 14 plus 1, 15 sort of, and maybe 18 students, but there's 50 that takes the course. Now there's one that said he cannot attend. Good morning, Benny. Good morning, Nick. Slovo. Morning, Mr. Kumede. Zivake. Kumede.
Good morning, sir. Good
How
morning.
are you?
I'm good.
Good. I'm also good.
Good morning, Prof.
Good morning. Who's that saying now? Mr. Kumede or Mr. Ndlovu?
Ndlovu.
Okay. Morning, Itumaleng. Good morning, Glory.
Good morning, Prof.
Morning, Innocent. Thank you, Itumaleng. Morning, Priscilla. Morning, Tapelo.
Good morning, sir.
Morning.
How are you? How are you
I'm
guys?
fine, thanks, sir.
Very well, thanks, and you?
Fine, thank you. Okay, I'm glad. I must say this is a wonderful day. But all days are wonderful as far as MIP780 is concerned. So I must tell you, this is a wonderful subject area. But as one of you said, there's quite a bit of work involved. That is true. But when you've done all that work, you will really know something about the subject of maintenance. You will really know something. That's why it's called maintenance practice. It prepares you for the practice of maintenance. I must tell you one thing, that you won't be an expert after this course. That you won't be, because it takes time to become an expert, and also it takes time to assimilate all the information and to make yourself become an expert. I have a new process called the 7 assets of asset management, the 7 assets program. Now that program is a program running over a year, and that is meant to really prepare you for life as an asset manager, because it prepares you to become an expert in the field. So that, but in terms of MIP 780, a 3-day course at university, although there's a lot of good information in here, you cannot expect to become an expert with one subject. Okay, I see that there is now 30 30 students in here. Mr. Ndlovu, you want to say something?
Yes, Prof. I just wanted to ask, we use the word asset management and maintenance management sometimes interchangeably. Can you maybe please just highlight what's the main differences between asset management and maintenance management?
Well, the main difference is that asset management is a much wider subject area. Asset management concerns the subject, the asset, concerns the asset, the buying of the asset, the eventual scrapping of the asset, the whole life cycle of the asset. So it concerns all of that. It concerns looking after, and it also it concerns looking after the asset, and that part of looking after is maintenance. In other words, caring for the asset is maintenance. But in the early days when people started realizing that one must look at the asset wider than only at the maintenance of the asset, they devised a name for it. They called that name terotechnology. Now, terotechnology, the tero part comes from the Greek terrain, which says caring, so it's caring technology. So they even called the asset management caring technology at that stage. But the difference is that asset management is a wide subject. It's a wide subject, whereas maintenance is just the physical caring for the asset. Yeah. Does that say something, Mr. Ndlovu?
Yes, you answered my question. Thank you, Prof.
Okay, sure. We're now 32 and one joining. Well, yeah, and one joining. Mr. Chown, Matthew, good morning. Mr. Kiran Naidu, good morning.
Good morning, Prof. Hope you're well.
Well, I'm working on it, and I've said so many times that I'm very well this morning. But I'm very well. Marguerite, good morning. I'm well, Marguerite, and you?
I'm very well, thank you.
Good morning, Mark. I'm well, and you? I now say I'm well up front.
A few of us were in a test classroom, so we were waiting for class to start, but unfortunately we were in the wrong classroom.
Oh, yeah, it won't work there. It won't work there. And then you realize that you need to be here. For sure, you have a test. For sure, you have a test. We'll do the test just now. When we've got everybody here, it's now 8:38, so we should have started already. I don't know why you guys always come late. We need to be 50 students, but okay, I think I'm going to start. I did not realize that we are already on time. So okay, so I'm going to start. So this is the second last day of MIP780, which is really the first last day. You know, there's 4 class days. The first one was just an introduction, and you had slides for that or videos to repeat that for those of you that did not attend the first class day. So all of that was there, and then we opened up all the work for the first cycle, first class cycle, and so you had 4 subject areas and quite a few videos and material and so on, and you had an assignment. Now, I must just say regarding the assignment, I said yesterday that I'm giving you an extra week on that because of the lot of late entries. Things was a little bit confused. I think even yesterday I made a few changes to the groups. The poor group 2 was I think 7 students and 4 of them left, and we put another 4 in there. So group 2 only has had 3 students up front. Okay. So the day schedule is, and of course this is for in class, but this is the schedule as it stands. So session 1 is 1.5 hours from 8:30. Then a tea time, and then session 2 again 1.5 hours, and then an hour lunch, and then 1 hour which is used for the workshop. But because we're online, we do it a little bit differently. But that is the formal schedule. So how we do that is that is the day's menu, the content of the day. So there's an introduction, an overview of 10 minutes. Now we've already spent 10 minutes, so we're a little bit out of time, but it's okay, we will make it. Then a test of 30 minutes. Then you evaluate your co-group participants. You have 5 minutes for that. Then you have group presentations. Each presentation 15 minutes. So we'll start with group 1 and we'll stop with group 7. Normally on the next class day we will go from 7 to 1, and on the last class day we will start in the middle and progress towards the sides. So that's how we do it. But today we start with group 1 and we stop with group 7. We have a tea time in between there, which we will see what we will do. We have the modules for class day 3 we will then introduce. And then we will do an introduction to module 6, replacement, which is quite a nice lecture, I think, which you need for the workshop, sort of. And then you do the workshop. Now, how we will do it is the workshop. By the time I've done the introduction to module 6, replacement, the workshop I will give to you in your groups for Friday, for handing in by, well, let's say next Monday, by next Monday. So you have to hand that in by next Monday. So each group need to do that workshop, and you can assist one another, and you can develop one answer for that workshop together. There's seven people in each group, so you can do that, and then you hand it in by next Monday for marks. Right, so that is what we will do regarding the workshop. So I'll just prepare you for that, and then you can do that. The other thing is, what else did I want to say? Oh yes, and the modules for class day 3, I will not open up in this week. I will open it up late in this week. I will start opening it up. I'm a little bit behind with my development of new videos for you, but you will still be busy with the assignment. So we have 6 weeks between now and the next class. So the first week you will expend in completing the assignment. And the one of you that said that he wanted, he thought to maybe stop the course, and this after my message yesterday, he decided to go on. He has some time to catch up. and you have to do that workshop for next Monday, and you have to hand in the assignment by next Tuesday before midnight. Okay, so that is what you need to do, and so on. So let's see what we have for the day. Okay, so there's a, oh yes, let me just go back. So the first thing that we have is an overview of what we already did. It's a there's the ClickUp. The coloring is different to what it is now. That's an old one. That's how it looked at that stage. And then we just talk about the. I just have to go here to my other set of slides to look at my notes. Okay, so then we have the upside down classroom the approach that we use. So that's the cycle through which we do our work. So what we do is we start with this one up right on the right hand side, experience. So we start with that, and that's the class that we have. So today we have this class. The experience is giving you something, and then you go, and the next thing that you do is you go and consider what, and then you consider so what, and then you consider now what, and then you come back for the next class, and you come for experience. So what we have, so that's the order in which it takes place. The experience is the main thing that we're talking about there is the project in the class, is that the class workshop, which is the one that you will hand in by next Monday. And the what then, this is then your study at home or work or wherever you study. So this is your study for the weeks that you are not in class. And then the so what is where you talk about that. You talk about that to your co-group members in the discussion forum, and you prepare yourself for the material. And the so what part of the so what is also the test that you come and write, and the group project that you have to develop a set of slides for the next class. And then the now what is then in class, where you are in class like you are today, and where you then present the group project to the class. So that's the idea. That is how it works. Now, if we look at them one by one, this is now today's class experience. It says up here. So it says what is it? It's an experiential exercise that we're doing today. It's done during class. You have exercises, typically Excel, which we use typically Excel. And the purpose is to have students learn by own work while having lecturers to assist. Now, if we're in class, then you sit in a computer laboratory, and the groups can develop the work together. Now, I've decided to give you the work, and you as a group go over the next week from today until next Monday, and you go and develop one answer to that workshop. And we hope that works very well. It depends on what you put into it. Now, regarding this experiential engagement, John Dewey, with two other guys, were the founders of the experimental learning approach. It's Kurt Lewin and Jean Piaget. They were the founders of the experiential learning approach. And that was many years ago that they said that the nature of experiences is of fundamental importance and concern, and fundamental importance and concern in education and training. People learn experientially. It is the teacher's responsibility to structure and organize a series of experiences which positively influence the individual's potential future experiences. So that's the idea. Although we cannot have experiences for everything that you are studying, but we want to try and get the most important thing. Oh yes, there's some noise here coming through. One of yours microphones maybe. Mr. Kabunde left the session, it says. Okay, so that is then the experiential engagement. That's quadrant 1. Quadrant 2 then is then concept exploration. There you study on your own. So you go back and you go and study on your own. It's done at home or work. It includes the study that the lecturer suggests. You work from a textbook, in our case textbooks, videos, etc. You do web exploration. You discuss with your group members through online chat, through WhatsApp, in our case, and you participate in that group. So it says forum participation, but we don't have a forum. The forum is the WhatsApp group. So learners here are exposed to and learn concepts touched upon during experiential engagement. So that's the idea. They also explore what the experts have to say about the topic. So there's quite a learning process involved. As you know, you've done that with the first 4 sessions already. Hopefully you have done it. And then the next step after that, after you study on your own, let me just say why is it so important that you start early in the cycle? Because of this one here, quadrant 3, meaning making. You first have to do the study before you can start doing meaning making. You cannot meaning make if you've not done the study. So this follows after, and the assignment is very much a part of it. You see there, you apply your knowledge on your own. It's done at home or work. It includes assignments, tests at the start of the class, and you perform certain tasks such as analyze data using spreadsheets. In this case, for our workshop, you will do that over the next week. You will develop that answer to the workshop. And it's not a difficult one. The only thing is you need to do it. You need to do it. Okay. So and that means that you have to develop a spreadsheet for what. So that is the job, is to develop a spreadsheet for what we want to for the problem that we're giving you, so that you analyze using that spreadsheet, and you hand in that spreadsheet with the answer. That's what you do. That's what you do. Okay, so you apply your knowledge on your own. And you cannot do that if you've not done the studying work. We do say that one must regard the assignment as part of your study. So all the time while you study, you're also doing the assignment and so on. So it's not as if you just do the one and then the other one, you do it maybe half and half together. But the fact is that you need to do the 2 steps. Concept exploration. that we had on the previous step, and then I must just get to my notes, and then this meaning making. My note says that learners reflect on their understanding of what was discovered during the previous phases. So that is what is done there during the meaning making step. And then the last step, the quadrant 4, is then demonstration and application. So in our case, it's the group slide presentation. You come and demonstrate what you've learned. Examples are you do a group project to find out more information on a certain subject area, and that will now be in our case also the workshop that you will hand in next Monday, the workshop result, and you will develop an own portfolio for presentation to the class. Or no, that's a possible thing that one can do, but we're not doing that. So we're doing the group slide presentation. That's what we're doing. So the purpose of this is to demonstrate what have been learned. You create something that goes beyond understanding the material. That's why we said that this group presentation must not be based on the material, but must be something additional. We will allow five individual students to present a short slide presentation in class. Class members will give their opinions regarding the presentation, so that we will do today, and that and marks will be given. So that's how we do it, as it is explained in ClickUp. Okay, so that is then our overview. So what we now need to do is we now need to do the theory test. I see we are, of our 50 students, we now have 42 in class. Okay, but we will now do the test. So if you log into you are logged into ClickUp, of course. So I'm going to open up the test now, so you will see it appearing on the left-hand side. I just need to do that now. I just want to get there. I just want to get another window because I don't want to close my slides. Okay, so I'm getting there. I'm now going to the test, down to the test area. It's below the classes. The assignment that you had the marks in this class organization, and then we have tests. Now first I want you to do an honesty statement on the left-hand side now. So you must go in there and you must answer 3 questions. Just say that you are an honest person. I just want to get in there myself. Where is it now? Okay. Honesty declaration. This item is hidden from students. Oh yeah, that's what you say. Edit the test options. I'm sorry. I must just say, make it available to students. Yes. Sorry for that oversight. Okay, so there you have it. You can do that honesty statement. So the big thing of the honesty statement is what I normally do is I wait until all students have filled that in. But what we will do is if you've not done that honesty statement, no, the test is still coming. But the moment, what normally happens is that I check whether all students have filled in the honesty statement before I open up the test. But I'm not going to do that now. The way in which I'm going to do it is you've not done the honesty statement. If you don't have 3 out of 3 yeses in the honesty statement, then I will not, and I will disregard your test marks. I think that's the easiest way to handle such a big group of students. Okay, so I'm going to open up the test now, and so you have to do the test as well, but your honesty declaration must be filled in 3 out of 3. Otherwise, you don't get the marks of the test. Okay, so that is the easiest way to do it. Let me just get down to the theory test now. No, man. No. I'm sorry. I just have to make the link available first. Where's the link? I have such a long list of stuff. It's not even true. Show the link. Okay, so now you will see the link, and then I must make it available. Edit the test options. Make it available to students. Yes. Make it available to students. Submit. Okay, so now it should be available to you, and now you can do the test. And you have 30 minutes for the test. And it is Mr. Coetzee, you want to say something, Mr. Mark Coetzee? No, he's lowered his hand. Okay, so you now have the test. You can do the test, and after 30 minutes, it will auto submit. You say that you can't see it. It's on the left-hand side. I'm sure it's there. Is it not there? Let me just go. Yeah.
Prof, do you mean that it's on the ClickUp page and it's right below class organization?
Yes.
Because my tab just says tests and there's nothing to interact with.
I'm sorry?
Because
class day 2,
yeah.
It says class day 2 theory test.
I don't see anything. It just says, just below class organization, I just see tests, and there's no interactive tab below that.
Do you see the theory test honesty statement?
No,
yeah.
I don't see anywhere my ClickUp, and I've reloaded it a couple of times now.
Well, on my page, it says that all those things are available. So it says, yeah, no, it's there. Tell me, any one of you, of the other students, just tell me whether you see that or not. Please, just tell me. Okay, I'm listening.
No, I don't see it either. I see the
I'm already
test,
inside the
not
test.
the
Mine's working.
Yours is working. So you see, if one is working, then all must be working. So you can't see it. Found it, reloaded. Okay, missed it. Yeah, I'm writing the test. I've seen it. So it's a question of your browser or something. You have to reload or whatever. There's a lot of students that's busy writing it. Unfortunately, I'm not there. Otherwise, I will. If it was in class, I would run around and I would help one by one student. But now I can't do that. Now you just have to reload. Luckily, it is timed. It's a timed session, so you only it only starts timing you when you start the test. Yes, Mr. Rikotsu.
Prof, I wanted to ask, what part of the tab is the test? Because I'm going down to the test tab and I'm clicking it and I see nothing. I'm not sure if it's in
No.
another.
You must reload your page. Then it's not showing it yet for you. So many students had that problem. So you have to reload, even if you have to reload your whole browser.
Okay, I'll just log in and log off. I'll just exit and come back. Is that fine?
Yeah, I think you must exit and you must close your browser.
Okay,
Open your browser again. Log in again.
Because I have two computers on here. Is it fine if I log on the other one?
Yes, of course.
Not a problem.
Of course. Just tell me, Mr. Rikotsu, if you get in.
Yeah, it's working now. Thank you, sir.
Okay. Good. Sorry, I still cannot see anything, and I've reloaded and logged out. Well, you must keep on doing that, because what can I do? You must get your computer to realize your browser. You must close the browser. You must close the browser completely and open the browser again. Because you sit with the problem that you have the memory of the browser that remembers how the page looks and then load it again without really reloading. That's the problem. I will tell you what I've learned now is that I must open up those links the day before. I don't need to make the test available, but I must open those links on the day before. So I'll do that in future.
Prof, from my side, I'm struggling because it says I've already completed the test. I was saving question 1 and I'm not able to go to question 2.
Okay. Who are you?
I'm Glory.
Yeah. I'll have to make a special arrangement for you. Just a moment. I must go to that test. I'm opening up another browser window.
It's the same with the honesty test. I've done this first honesty statement. I said yes, and when I go to the second one, it says I've completed.
I don't know what happens. I don't know. That's strange. I'll say to theory test, and I'll do the same with the honesty test. I just have to get in here, edit the test options. Availability exceptions. Okay, what is your number? Because I think it's in group number order here. Yes. What is your? It's you what?
Glory Nobo.
No, your number. Your student number.
Student number is 18382.
Just a moment. I just have to. Okay, now it does not give me the full set of students. Your number is now too high up. Search any. Oh, okay. I can just give me that number again.
183.
183. Okay, 183 is okay. 183 is okay. Let me just go there. Just see what I get. Search any not blank. U 183. Oh. Does it not come up with you? Glory. Let's say Glory.
Yes.
Maybe that will work. Search any. What else is there? Name. Name, Glory. Glory. Username. Just give me your full your student number. 183
82
82.
682.
682. Oh, this thing gives me a pain. Oh, okay. You say it's 182.
Start with 183, 82.
Yeah, but what? It now gives me the full list, but now it is not. Let me work through the students because it's in no order. Oh, there is chlorine and coal. Okay, so there you are. So I must submit you as an exception. And I'm giving you multiple attempts. Okay, submit. Okay, the number of attempts is not valid, so I must put a number in there. So let me make it 3, just to make certain. The number of attempts is not valid. Say clear. Now what the heck does this thing do now? They change things that works and then it multiple attempts. Number of attempts is not valid. Oh, 3. There it says. Submit. Okay, now you have three attempts. There's another 2.
For the test.
Yeah, and I will also do it for the other one.
Thank you very much.
Okay. Honesty statement. Edit the test options. And if we don't get through this, I think we have to go on with the class. Availability exceptions for that one is name glory. There you go. This one. Multiple attempts. I get 3. And we submit. Okay, so your honesty declaration is now also right. I just want to check on your tests. Okay. So it seems as though most of you have written the test. Looks like that. Right, so let's go on with the class. Let's go on with the class. The next step is your evaluation of group participants your co-group participants. But I think that is also not, the link is not shown yet, and because of that, I wonder whether we should, let me just see, class 2 variation of group participants. It's just underneath this link for the class. So I've made it available now. Just underneath the class 2 online, it says evaluation of group participation, class 2. And then I must just made it available. Now you will see that if you look at that, that evaluation of group participation, you will see that what it says there, I just want to read with you. It says you have to rate the participation of your group members on the scale presented. The group member list has been given numbers for each group member. In other words, on the left you have group member 1 to 7. So you must use those numbers for your group. You just do it for your group, and you do 7 answers for the seven group members. And each of them, if a group member does not exist, or the member has left, or if you do not know that member, then you use the not applicable option. Okay. So you have 6 options, starting from that the group member has been very involved up to nothing involved, that's number 5, and option 6 is not applicable. So if you don't know the person, or the member has left, or there is no member, then you say not applicable for that specific group member. Okay. So Mr. Jacquedera, please tell me what you want.
Okay, I just wanted to confirm, because some of us, I think we only knew our groups last night or early this morning, because we late entries. So, I mean, in terms of evaluating, we won't be able to do anything there.
Okay.
Yeah.
It's a little bit difficult because that affects your marks as well, those evaluations. So if you've not, then you just say not applicable. I think that's a rule. Then you say for each group member it's not applicable.
Okay, all right. So take the marks.
Yeah. Okay.
All right.
Somebody still said that it doesn't know where it is. It's just below this class link, just below the class link.
Sorry, Prof. On my ClickUp, I don't have a group evaluation anyway.
Again, you might have to what do you call it? Refresh your page, because it's there. Can any one of you say that you've seen it? You have that link? Yes, I can see it. I also don't see it. Yes, I see it. Mr. van der Merwe, I'm doing it, Mr. Reineke. So yeah, I see it. So it is just a question of you see, one student said that his internet is not working. They phoned, apparently.
So
Okay, Mr.
may I
van der
ask a
Merwe.
question?
Yes.
The WhatsApp chats, when do we export it to and send it to Prof?
I think in this case, after next week, after you hand in the assignment.
Okay, thank you, Prof.
Okay. Because you will be talking to group members still during this week for your workshop and for the assignment, maybe whatever. Mr. van der Merwe, your hand is still up. Okay, there you go. Okay, so I suppose that your evaluation of group participants have been done. I hope so. And then our next step is the group presentations now. So what we now need to do is we need to get group 1 to upload your group presentations. So you go to the sharing button, the one in the middle. Well, if you open up the part on the right hand side of your page, you have the button for messages, and you have one for participants, and then you have the one for sharing. So you must go to that one, and then it allows you a file upload. But before you can do that, you must tell me which of you are, for group 1, will be the uploader or the presenter, whatever, because I must change you now an attendee only, and I must make you a presenter. Yes, Mr. De Beer, you say. For group 1, it would be Jean-Ray De Beer who will be presenting. Okay. Group 1, Jean-Ray De Beer. Now I must just find you here. Jean-Ray De Beer. Right. Make a presenter. Just check whether that is so. Where the heck? It does not show that. Jean-Ray De Beer. Okay, there it shows it. You are a presenter. So you can upload your stuff. I'm going to stop presenting my sharing. I'm going to stop my sharing. Now what the heck must I do now to stop this? Oh yes, I think it has a button up here which I must close captions. Thanks. Let's do that. Okay, now I've stopped sharing. So, Mr. De Beer, when you're ready, you can start. Or just give me another moment after you've uploaded.
Prof.
Yes.
I did not get the group evaluation tab. I've even logged out and logged in. It's still not showing up on my part.
Okay. You have to keep on trying because that's the only thing to do. That's the only.
There's a refresh little thing you look on the MIP group. There's a refresh button on the top where MIP780 calls is. If you push that, it works.
Okay, on the ClickUp page.
All right, thanks. I got it now. Thanks.
Yeah, so on the ClickUp page itself, on the MIP, on the main window for MIP, just above where MIP is, there's a little refresh thingy that works when you updated the links.
Oh, I'm battling.
Hi, Prof.
Yes.
I'm trying to share the presentation, but there's no. No, it just says presenters and moderators may share content, but it doesn't give me an option to share.
But you are a presenter. Just a moment. Just give me a moment. I'm battling with a thing here because something. Let's just get my computer to do what I wanted to do. Okay. I think I'm roughly where I need to be. Okay, so you say, let me just go in there again. To the group of attendees. Mr. De Beer. It says, Mr. Jean. Oh no, I changed you to a captioner and not to a presenter. I see. That's what happened. You're now a captioner and a presenter. And whatever a captioner is, you're now a presenter. I'm sorry. Sorry, Mr. De Beer.
Prof?
Yes.
I'm having the same issue as that lady. When I went into the declaration, it just automatically saved that I've submitted, even the
Yeah,
test.
but leave that for now. When we're finished with the class, I will handle those that still sits with that problem. Okay.
Oh, okay.
Yeah. Okay. So Mr. De Beer is sharing content. For the moment, my screen is completely confused. I don't see your content. I see a. No, you know what you are doing now is you are sharing your screen, and you need not do that, Mr. De Beer. You must go into the share content page, and then it says share files, not share application or screen, share files.
Okay.
And then you must upload your PowerPoint. And when you upload your PowerPoint will be shown, and then you click on that, and then you start presenting.
All right,
You
it's busy
okay?
uploading.
Okay. Just group two. Group two. Who will be the presenter for group two? I see your group now, or your slides, Mr. De Beer. I see it. Group two. Who will be your presenter? Let me rather get that done. Let us do group two and group three as well. Let me quickly do that. Group three. I will upload Mr. Deploy. Okay, let me just change Mr. Deploy. I wish this thing was alphabetic, because now I have to run through the list to get to Mr. Deploy. Ons raad 'n man laat te gaan. I catch. So, Deploy, there you are. Okay, so I make you a presenter. Okay, so you're now a presenter. And group two? Who is group two? The presenter for group two. So, Mr. Deploy, you can now upload your PowerPoint. Yes, Mr. Mviana.
Good morning, Prof. I am on group 2. Can you hear me?
Yes, I hear you.
I sadly believe we are not ready with the presentation on group 2.
Oh, that means you will get 0 marks. Seems like.
It seems like yeah, we are beginning to get ourselves together, but be that as it may, we are here right now.
Okay.
Yeah.
I will allow group 2 to because group 2 are the one where four students left, and I added another 4, so I understand group 2's problem. So I think what I will allow for group 2 is to do the presentation, to develop the presentation, and maybe we have to make a session where you can just present it to me.
Yeah, that will really help us just to get on our feet. Yeah, thanks a lot.
Yeah, so we do that. I think next Monday as well, but I first have to check on my availability. But I think that is what we will do. Mr. Chown is for group 5. Mr. Chown is for group 5. Let me just get to Mr. Chown. I make you a presenter. Okay. So I think you are now a presenter, Mr. Chown. I'm the presenter for group 4. Is Miss Pina. There you go. Make presenter. Okay. So we now have group presenting group 6 is Venter, Karina Venter. I think you were right. Yeah, very near to the bottom. Karina Venter. Oh no, I have the wrong one now. Karina Venter. Make presenter. Okay. Yes, Mr. Vuyana. Your hand is not lowered. Your hand is still up. Okay. So I now have 5 presenters, and I need a 6th one. I'm not sure which group now for. Maybe group 5, is it? Who's the presenter for group 5? Mr. Chown. Oh, okay. So group 4, I think, is Mr. Deploy, I think. Group 2 is not presenting, I know, but there's 7 groups, so there must be 6 presenters, and there's now 5 presenters. Ms. Penna, Mr. De Beer, Mr. Chown, Mr. Deploy, and Ms. Venter. Group 7. Chown used for group 7. Okay. So who's the one that's still left? Okay. Chown is group 5. Okay. So Mr. De Beer is for group 1. Group 2 we're not doing. Group 3, who's group 3? Presenter. That Mr. Deploy, I'm not sure. I just have names now.
I'm presenter for group 3.
Okay, Mr. Deploy. Now who's for group 4? Is Ms. Venter, is it? Or which group are you? Karina. I see you talk, but I don't hear you. Maybe you must just type.
So as far as I know, John De Beer is group 1, I'm group 3. Group 4 is Vanessa Penna. Group 6 is Venter. Group 5 is Joan. So we need group 7.
Okay, so we need group 7. Now, who is group 7's presenter? Group 7. Let me just see. Group 7 is Emmanuel Daya, Tapelo Manjelo, William Morafu, Samakusin Kabunde, Nicolelo Rutsuane, Mr. Ngema, yeah? What do you want to say, Mr. Ngema? Vian Reineke is also group 7, and Archie Mavele is group 7. Archie Mavele was only added yesterday. They lost Brandon Jean-Jacques. Okay. It seems as though group 7 does not have a presenter. So, okay, so we start with group 1. Mr. De Beer, the floor is yours.
Right. Good morning, class. Good morning, Professor. We are group 1. Today we will look and focus on the lubrication module and ask the age-old question, is synthetic oil better? So as a group, we went and we did some research on just the difference between mineral oil and synthetic oil. So we know in the industry we are growing and we want to have our equipment as reliable and as available as possible. So thus our equipment is becoming more sophisticated, the demands on lubrication is becoming more strict, and we focus more on the physical characteristics of lubrication even more. So thus the only options we have is synthetic oil and mineral oil. So for mineral oil, this is developed from crude oil itself. The molecular sizes of the components differ a lot, but as technology advanced, there is a process called hydrocracking. So this hydrocracking will remove some of the impurities and also lessen the difference between molecular size structures. Thus, mineral oil today can perform the same as PAO oils, which is synthetic oil. On the other hand, we have synthetic oil, which is completely man-made. The synthetic polyalpha olefins, the PAO, which we mentioned, that is the main characteristic of this oil, the main structure in it, and there's similar to no difference in molecular sizes. As you can see on the pictures that we have here, we can represent mineral oil as gravel, basically. We have all these molecules together, but none of them are the correct size. Then on the other hand, you have your synthetic oil, which is basically these ceramic pebbles, all of them very close in size. If you have motion across them, you know all your oil is actually carrying the same type of load, evenly distributed. So because we have hydrocracking, we start focusing more and more on the additive packages in the oil, not the difference between mineral and synthetic oil anymore. So as a case study, we were looking at the primary gyratory crusher of a mine here in Mogalakwena. So just to give you some background on this crusher, so the main shaft, which is this big silver arrowhead portion, this weighs about 37 tons. It is choke fed, and at the time it crushes 90 tons of ore. So the only thing that's keeping this whole massive main shaft against the eccentric gear is a aluminum brass bush, which is situated there, and the only film between that is your lubrication. So there you have not a lot of tolerance for your lubricant to take place, and this is the only thing that protects the crusher from being damaged day to day. So the problem statement that we're currently sitting with is that the eccentric bush of a structure, it normally lasts about 2 months. This is when you start having impurities creep in, and then you start having fatigue and macro pitting on the shaft and the bush itself. So macro pitting, this is where there's a hard particle which plastically deforms in the surface, and this starts creating subsurface stresses, which then initiates crack. As you start having more and more cracks, your main shaft, as you can see on the right hand side, they should actually be quite smooth. You can see the black marks on it, which means it's quite pitted due to your macro pitting that has been taking place. Due to the cost of the shaft, which is around about 5 million rand to replace and to manufacture, you don't normally want to change the shaft, you rather change the inexpensive part, which in this case would be the bronze aluminum bush. So if you have a failure every 2 months, each failure costs you 350,000 rand for the bush, 150,000 rand for the labor to strip and open up the crusher and put it back together. Thus you sit with a cost of 500,000 rand per breakdown. And that excludes all your revenue loss, assuming that you have enough stockpile to keep on feeding the mill in this concentrator plant. So the original oil type used was the mineral oil Total Meropa 150. Then the company trialed the Castrol Octagear BM150 oil, which is a synthetic oil with a good additive package as well. We will quickly go into the details of the additive in the additive package. So the additive that is in here is TGOA, and it's a PD additive. This is just your classic deformation. So TGOA is the tribal grease oil additive. So this additive works in 3 steps. So step 1 is you have your conventional extra pressure additive. This just starts forming a sacrificial layer based on sulfide on the surface, just to prevent the adhesive wear of your asperities of the bush and the shaft touching one another. The next step will be the liquid solid phase. We have your molybdenum and sulfur based compound, not molybdenum disulfur as you would normally achieve. So this forms a permanent stronger layer on the surface, thus reducing your friction coefficient, and it also starts taking away the asperities. On step 3, this is after a week of operation, due to all the continuously increasing loads, additive starts to diffuse into your metal surfaces. As it starts diffusing, it initiates micro smoothing and then forms a very dense, tough cushion. So there you have a sacrificial layer on your shaft and on your bush itself. So that will reduce your peaks and valleys by a factor of 4. Thus, the smoother the surface, the less chance for wear. And then the outcome of this was, from the oil itself, from the mineral oil to the synthetic oil, we moved from 3,000 liters per 210 liter drum to 18,000 liters per drum. So the crusher itself, to do an oil replacement, uses about 10 drums. That's 180,000 rand replacement. So return on investment in this case, seeing as our mean time to failure was 2 months, the return on investment period would start right after the 2-month period. So in this case, that would be 21 days to pay back the 180,000 rand of the oil. So currently, the actual mean time to failure at this plant is 8 months between bush replacement. Thus, if you take that period of 8 months and divide it by the 2 months, you're sitting with 4 times the cost that you would have paid, which is about 2 million. So the 8-month period, you have then actually saved 2 million rand just by making an investment of 180,000 rand. So then let's us return to the question: is synthetic oil better or is mineral oil better? So in this case, if you have synthetic oil with the correct additive package, it will be better, but all of this will depend on the criticality of the equipment, if it's heavy cyclic equipment as well. So I mean, you do not want to have a gearbox which is not on your mainstream of your equipment running on oil which is 80,000 rand per drum. Then you would rather risk it and go with the mineral oil of 3,000 liters per drum. So the cost benefit in the business must also be taken into account before making any harsh decisions. Yes, and that's the presentation from Group 1. Are there any questions?
Anybody with a question? Seems as though you've done your job so well that that they don't have questions. There's nobody with questions. I must say that I'm amazed at the result. It's very good. It's excellent. So am I right that it's now up from 2 months to 8 months roughly?
Yes. Currently, they are trying to see how they can improve it. So the shaft that was pitted, they did remove it and they installed a brand new shaft, which the surface roughness also decreased a bit. That also assists quite a lot in ensuring that you have less wear on your bushes.
Okay. Okay, but it's really amazing results. Amazing results. It's it gives me a lot of information. So I'm impressed.
I have a quick question with regards to taking into account.
Is that the choke?
Yes.
Yeah. Okay.
With regards to environmental hazards, will this have to be discarded in a much more safe manner than typical than other oils, or is this much easier to discard? Yeah.
Yes, it will follow the same process as other oils. Mostly you will look at your MSDS on the oils. But for all oils, it's more or less the same. All of them are quite bad for the environment. So we have a company on, I know there's a company on site which also removes the oil drum. So you put all of that in hazardous skips. And from there on, they take it to a company which specializes in taking care of hazardous waste.
Awesome. Cool.
Okay, I've opened up the evaluation of Group 1's presentation for you at the bottom. It says Day 2 presentation votes, Day 2 Group 1. And I'm opening up the other ones as well, so I just want to show all of them. So please evaluate Group 1's presentation.
Sorry, Prof. So group 1 voting for group 1, isn't it?
Yeah, group 1 can vote for group 1 as well.
Oh, okay.
You can
Sorry, Prof.
upvote your.
I just wanted to ask,
Yes.
I didn't catch where you said the evaluation is. I'm sorry about that.
It's right at the bottom, day 2 presentation votes. So you go for day 2 group 1 and you do that evaluation. It's a simple little evaluation where it just give your opinion regarding the presentation.
Okay, I found it. Thanks. Thank you.
Okay. You now, I now also see at the top of that, of your menu, you have that little refresh circle that you can press on to refresh when you don't see something. I'm glad that you told me that. Mr. De Beer, I'm changing you to participant again. Thank you. There you go. So who is the presenter for group 3?
That's me, sir. Well, I mean, all of us are having each other's slides, so we sort of did a different approach.
You have a different approach? What is that?
Each of us did so what we did is we took a hydroelectric power station, and we tried to see in which ways can we use the new information that we learned and apply that to the system. So each of us has our own slide as we prepared it.
Okay, but the slides are now all in the same slide deck.
Yes.
But it's a slide per person.
Yes.
Okay, so you say hydroelectric power case study. Okay.
Okay.
You can go.
So what we did was we decided to take all of the information learned with regards to asset management, maintenance planning, lubrication, and failure. And we took a case study and we said, if we select a hydroelectric power station, how can we apply this new knowledge and break it down into different parts? So the first part would be the asset management part, which will be covered by our first group member.
Morning. Yes, I will come in. My name is Edwin. I'm presenting for Group 2. The portion is asset management on how we'll be managing this plant in totality. So just to ensure that the plant is managed effectively, and so policies and strategies and the right expertise is acquired, and so is the objectives. There's a design of the maintenance structure that will support that, and this structure is commissioned. So the structure that is then chosen for this purpose is a strong matrix structure, as you see on the left-hand side top, which is called the technical director and the engineering, and then the manager of project and construction on the other side. We're focusing on the engineering side, which then we further exploded on the far right top. So we felt that this structure would be appropriate to manage this plant, which then have an engineering manager. And then we also have a central services there, which is documents management and the information of the plant. And then we have a cluster of project-based maintenance. So this one shutdowns, modifications, maintenance engineering, and because the plant is also highly technical, we also have automation control there. Then the technical support is maintenance group, which is preventive maintenance group, and the corrective maintenance group, which we'll talk about it now. And then we also have the spare parts store, and then the chemical store, the machine shop, and then most importantly as well, we have the automation and the instrument shop in this structure to support this asset. So then the cluster of maintenance or roles that then are here and their responsibilities are further details here. Cluster 1, this is the autonomous maintenance group. So really this is the first line. For example, they focus on cleaning, inspection, lubrication, and tightening. So this is really the small maintenance kind. So they also do the breakdown or the downtime registration and data collections, in the plant. There are also ownerships of the workstation or the operating areas where they operate. They do small repairs and then small breakdown maintenance, adjustments, and identification of faults and taking of those for attention by the other clusters of maintenance. So supporting then the cluster 1 is the corrective maintenance cluster or group. They then attend to breakdowns for the machines and they do registration. They also do inspection and lubrication at a little bit higher level than the cluster 1. And then they obviously do technical support. So if there's a breakdown, this cluster 2 is the first group that attend to that breakdown. They do breakdown analysis for the area and then identification of faults and tagging. And then cluster 3 is a preventive maintenance cluster or a group. So this group doesn't get much involved into smaller day-to-day breakdowns. They do preventive maintenance and then they do major breakdowns. This will be the breakdown that the cluster 2 is higher than those that the cluster 2 can help, or if the cluster 2 could not resolve it. Root cause failure analysis, equipment downtime analysis, such as Pareto analysis.
Okay, thank you. And then finally, that brings us to the failure modes. So obviously, a complex system like this has multiple failure modes, and this will be presented by our next group member.
Hi class, my name is Rubershin and I'm presenting the failure modes in hydroelectric power plants. So from these two tables on the slide, we can see they are containing percentage of incidents occurring in hydropower plants across Japan from 2004 to 2012. And we can see that turbines are the largest percentage of mechanical components that cause incidents in the plants, with 19.4% of these incidents resulting from machine deterioration and lack of proper maintenance. So turbine failure not only increases the plant downtime, it also brings about revenue losses and poses a serious threat to life of operational maintenance and personnel, especially when the powerhouse is underground. So there are usually 4 causes of failure in the operation of turbines. They are cavitation, which is either caused by turbine design or frequent changes in turbine operational conditions, depending on load. Then there's erosion caused by high fluid velocities coupled with sediment within the water, resulting in erosive wear of turbine components. Then there's fatigue caused by high cyclic stresses coupled with many interconnected parts that vibrate together that can result in material fatigue. And there's also manufacturing or installation defects. But from the 4 main causes, the main culprits for failure are a combination of cavitation and erosion. Yeah, that's the side done.
Okay, so obviously after failure, you need to plan so that you never encounter any downtime with something as important as a power station. So for this, because it's such a complex system, it'll be a combination of predictive maintenance and user-based maintenance, where the predictive employs a computer maintenance management system, which has sensors all over the plant. And these sensors all log key diagnostic indicators, key trend indicators, fault process, probability, and then fault severity index. So you can see from one panel exactly where certain things in the plant seems to be less optimal or are likely to fail, as it has a diagnostic system as well. And this ensures you that you can do preventative maintenance and do shutdowns using those clusters mentioned in the asset management, depending on how severe the fault is or how severe the problem, so that you never get into a situation where you have to shut down due to a turbine failure or something that's detrimental or overall a fatal failure to the plant. User-based maintenance will also be conducted in form of the scheduled visits. So depending on the size of your hydro power plant, it depends on how many, according to law and ISO standards, how many visits you have to have per year. The larger the system is, the more frequent these visits are, and they'll be conducted by specialized personnel that do any sort of failure testing and double checks the turbine integrity. And then each of these visits, all of those data is re-put into your computer maintenance management system. And this increases the accuracy that this software can predict failures. And then finally, of course, while working with water and while working with metals, lubrication is a very important part and will now be presented by our next group member.
So we said wear mechanisms and lubrication actually goes hand in hand, since a lot of problems or lack of poor lubrication cause a lot of wear problems. So first of all, different sorts of wear mechanisms. So if pieces is a metal fragment becomes detached and can be identified by flat metallic wear fragments. Abrasive is a result from hard particles trapped within contact surfaces and can be visually identified by surface inspection. Corrosion is wear in which chemical reactions contribute significantly to the rate of material removal and can be identified by presence of corrosion products elsewhere in the system. And then surface fatigue is cycles spaces generated surface cracks with product which produce pitting and spoiling of material and can be identified by surface cracks and wear deburrs. So then we said, let's think of a solution of it. So lubrication is, we can solve it by lubrication. So using lubrication in conjunction with the rolling elements to reduce friction, using appropriate additives to increase performance of the lubrication, perform adequate lubrication analysis to identify the contamination indicators. So then we said, let's look at lubrication and requirements in the industry. So one must use the correct viscosity, lubrication must support the load, and corrosion control, and also the chemical stability. So this table just shows like how it can influence and what must be considered. Yeah, and I think that's all from our side.
Yeah, so in conclusion, we applied all of the knowledge learned in the first block on a power station, and these are a few of the references we use for interest's sake. Is there any question?
Mr. Sikiso.
Yes, Prof. Just on, I've got one question on slide number 4, where it said, I think it's something like user-based will be carried out in the form of scheduled visits. I would like to understand the scheduled visit parts, like in the form of physical inspections. What do you mean by scheduled visits?
Yeah, so it's a formal inspection conducted by external auditors and investigators. So depending on how, let's say you have a 200 megawatt plant, I think that corresponds to twice a year visit. So that'll be an in-person visit as an audit to see if it's all up to standard. This will be conducted every 2 times a year, or depending on how big the facility is.
Are you happy, Ms. Sikisu?
Yeah, I understand. I understand what he's saying because I thought maybe scheduled visit in the form of inspections is more on your is it not condition monitoring of some sort? I'm not sure. But yeah, I do hear what you're saying.
Okay. Ms. Nkuane?
Good morning. Yes, I've got a question. I think it's in line with what the lady was just talking about. I think you were talking about on the same slide about doing a combination of predictive maintenance and user-based maintenance. And my understanding is that if you are going to move towards predictive maintenance, then you have to do more of condition-based maintenance, which is actually going to assist you to be able to predict when equipment is going to fail. Is there some sort of a balance of the user-based to condition-based that you're looking at? Thank you.
Yes, there is. So for everyday small faults, finding small leaks or stuff like that, it will be condition-based. And then obviously the predictive is more in terms of larger components. The large generators, the turbines, all things that are essential for the running of the system at 100% capacity. So that's the balance there is between the two. So you can't just do predictive, you can't just do the condition based. It has to be a balance between both.
Okay. Another question? More questions? Otherwise, I think you can go and evaluate Group 3's presentation, please. The link is there on the left-hand side. So you just go and you do that evaluation while we get Group 4's presentation up, which I am not sure which one it is. Oh, maybe just a comment from my side on the slides for Group 3. I just found some of the slides difficult to read. The one is the second slide, that green with the white lettering is very unreadable. The color, I think the color is a big contributor to that, the light green. And then also the other slide with the what was it now? Failure modes or whatever. That was also the size of the tables are a bit of a problem. One must maybe sometimes just take that same table and just overlay the one part of the slide with a bigger version of the. But that's not negative. It's just a little comment. One must always be aware of that. I find it all the time. It's a pleasure. Group 4, Ms. Pena.
Good morning, Prof. Are you able to hear me?
Yes.
Okay. Good morning, everyone. My name is Vanessa Pena, and I am presenting on behalf of Group 4. The focus of our slides are on failure principles and the renewal theory. As mentioned previously, this presentation is based on Module 2 and 3, which is about failure principles and the renewal theory. Before we get started, let us first define what failure is. More particularly, what is functional failure? Functional failure is when an asset is unable to perform its intended function or several functions at a specific standard. There are many causes to failure in a component, machine, or system. Failure could be due to metallurgical related failures, and this is split into stress-induced, such as creep and fatigue, and into environmentally related metallurgical failures such as corrosion. We know that rust weakens a material, which in turn affects its structural integrity. Another cause of failure would be due to design errors such as miscalculations made in the design stage of a machine. It is generally unsafe to create a mechanical design not adhering to design standards. An example would be the SAN standards, which are standards put in place for the performance requirements of a specific product. Poor installation is another cause of failure. This is due to poor workmanship or no quality control performed while a machine or system was being installed. Lastly, a machine can fail due to equipment mishandling. This is when operators of a machine misuse the machine. An example of this would be operating a machine past its maximum rated load. Prof, there's an error in one of these slides. It's kind of duplicating, like I'm not sure how everyone sees this slide.
Yes, it's duplicating.
Oh, that's strange. Okay. Is it possible if I re-upload it, because it doesn't appear like this in my PowerPoint slides?
Yeah, you can, maybe what you can do is we can stop here and we can do group 5, and in the meantime you can re-upload. I think
Okay,
that's maybe
fine.
the
Thank
best.
you, Prof.
Okay.
Thank you.
So let's then go for group 5.
Right here, I'm just going to upload it now.
Yeah, all of you can upload in the meantime. It's
I was too scared to upload in case it overwrites someone's file. I don't know how the system works.
no, it won't.
Okay, he's busy converting at the moment.
Maybe just a comment on your naming of your slides as well. It will be very good if you can call your name group
Yeah.
The group name, like group 3 is group 3 class day 2. That's very nice.
There we go. All right, you.
Oh, that's good. Group 5. Yeah.
Okay, great. It's uploaded.
Okay. And you can go. The moment that you're ready, you can go.
Good morning, class. I hope everyone's well. So today we're presenting on how a lack of maintenance leads to a constantly failing power grid due to Eskom's regulations and rules regarding maintenance. I'm Matthew Chan. We are Group 5, and this covers modules 1 to 4 for Class 2 for maintenance practice. Load shedding. So load shedding began due to a change of regulations and rules from Eskom's general idea of maintenance. They changed their system to reactive maintenance to save on costs, on short-term costs, and this generally led to an instability in minor components and equipment, which led to a failure of the national grid. The reliability of Eskom's machines, due to the fact that they are old and unreliable and unpredictable, they keep breaking down. So about 80% of Eskom's machines are over the age of 40 years old. So this led to reliability issues. Also, the load shedding, The load shedding from quality control. The load shedding occurred from quality control due to power losses in generators and boiler tube leaks. If this led from this, there are minor and major examples of this, of quality control not occurring in Eskom's reactive maintenance procedures. Eskom does have the capacity to supply the entire country with 45,000 megawatts, whereas the demand is only about 30,000 megawatts. But due to unplanned breakdowns, the available capacity is not met. Here is a minor example of reactive maintenance and the effects. The power station boiler, as you can see here, looks extremely hideous and does not look like a proper boiler. The inadequate cleaning routines degrades boiler efficiency. This leads to, because of reactive maintenance, this is because of reactive maintenance, sorry, I've lost my sentence somehow. Because of reactive maintenance, the cleaning does not occur, and the maintenance will only occur when it has actually broken down. This leads to minor power losses and inefficiency in the equipment. A major example occurs in substation boilers, where transformer cooling fluids overheat, producing flammable mixtures, which causes the substations to explode, leaving us powerless in the middle of our TV shows. Power losses occur from 5,000 megawatts up, where in 1 week 8 generator units can fail due to boiler tube leaks. With using reactive maintenance, Eskom failed to conduct the preventative maintenance testing, but rather chose to follow reactive maintenance, and they will only act once it is too late and the complete failure has occurred. The way forward for Eskom should be to introduce a complete redo of their asset management with specific focus on planned maintenance with condition-based or predictive maintenance. This will allow the capacity of the 45,000 megawatts to be used, but currently it is not being used. And this will gradually increase between 5,500 megawatts and 7,000 megawatts, or approximately 12%, due to planned maintenance. This will leave us powerful, as you can see, and we will at least be able to have our lights on during the night. The way forward is a better approach will be to apply predictive maintenance, as I've said before, and it is not based on reactive maintenance. The previous history of equipment is required, whilst the current condition of machines is also required, and a predictive life cycle of machines is also required. And then the constant monitoring of systems employed on the machines is also required, and this will leave us powerful. Yes, thank you. Yeah, there's my slide, my presentation. Any questions?
Any questions for the presenter. Now my microphone doesn't work properly.
Yes. Questions from Jean-Andre?
Find out how we're gonna. What's the plan that you have in place to get to a preventative maintenance strategy?
Specifically with the substation boilers, I think. Yeah, Njabula can answer that for me.
Hi. Sorry, who asked the question?
Jandre.
Jandre. My name is Njabulu. So I think what needs to happen, I think Mehdi has already elaborated the constant monitoring and also of the big machines, you know, generators or the power line, and through that gather enough data and then just sort of focus and if possible use sensors and sort of project from that using computerized maintenance systems that are available to focus that. But I think the biggest challenge what they have is that, you know, because they're so old and so many, they can't help but to react now because they just isn't that capacity. So I think like the planning using past data to project forward and focus that will help, and also using the OEM's manual. I have a family member who used to work there as well, and he mentioned that contractors sometimes were also not very skilled so maintenance would be done, but then it wouldn't be done according to standard. So I think skilling is also important, and just combining everything and putting it in the management system. I'm not familiar if they have such a forecasting system for predictive maintenance at Eskom.
Is that satisfactory answer?
Who's speaking at the moment?
Sponseni here, guys. As I have a small question, with regards to your question on do they have such a forecasting system, Eskom employs the system of risk-based inspection, and in certain cases where they've identified high scenarios where probability of failure is very high, they will go further by putting things like thermocouples and strain gauges to monitor vibrations and predict the failure. My question actually is around the ideology of the predictive and condition-based monitoring. Is it still applicable to Eskom when all your assets have gone beyond their useful life? Is it even worth doing? Or should Eskom really be looking at a complete overhaul, hypothetically, if it was financially possible?
Okay, the last term there. If it's financially possible, most definitely that is what Eskom requires. As I have stated, it's most components, most equipment is over 40 years old. I know for a fact that Kendall Power Station is about 50. Probably the wrong assumption there. And they're still currently using the power grid from 1990s, the control system there. So with regards to that, the major factor that comes into play with this is they cannot cannot adapt a lot of the system in power stations due to it being old technology. I think Sorry, I've completely lost my sentences here. I hope Njobula can help me along here, please.
Yeah. But I think the question of whether they should replace the equipment entirely, yes, that is obviously the first case scenario. And I think there's so many external factors that are preventing them from just replacing the entire fleet. But then I always think if you have an equipment, even if it's old, if it's the only one that you have left with, you still need to manage the expectations, right? And not just react when accidents happen. Like you didn't expect that boiler to fail. You should still reliably predict, like, okay, yes, it's been here for the past 30 years, 20 years. There's still a benefit in knowing how long that can stretch, no matter how far at the end of its life it is. So I think there'll always be a benefit of predictive maintenance, even for equipment that is old.
Question from our side. What about taking?
Mr. Kisu is the next one that has a hand up.
Yeah,
I think we must go.
Just a pointer from my side. Prof, great presentation, Matthew. I saw that you actually are on the slide that how a lack of maintenance leads to a failing power grid. Just a comment actually that would have been interesting to see the statistics, because I think ESCOM is a sensitive issue in the country and not just in class. What is your mean time between failures? What is your current availabilities? Just to see that that would probably maybe paint a picture to say this is currently where you are sitting as far as those statistics are concerned, and due to a lack of maintenance. It's just a comment from my side.
Okay. You can maybe react if you want to react, but after that it's Mr. Latergan then.
Yeah, I would actually agree with that. Unfortunately, I performed research in the wrong area of this presentation. I'm presenting the rest of the group's information. So currently I don't have this knowledge on the research, on the statistics. Sure, Carl or Andries can help me along there. Yeah, they would have aided quite a bit. If I had performed research in this, I would know what to say right now.
Okay.
Well, hopefully you tried your best. So yeah, but we take the point.
I think, can I go?
Mr. Latergan.
Just a comment. I think it's important to look at the statistics, as said before this. And what about taking it back to its original state or close to its original state and then implementing a preventative maintenance strategy to make sure that going forward you're in control of your assets rather than replacing for now or in the short term. Yes, it will cost a lot of money, but I think it will be cheaper to take it to its original state and then maintaining it rather than building a brand new power station. It's just a comment from our side. Or, yeah.
Well, you can go and evaluate Group 5's presentation. Mr. Deploy, do you also have a question for them? Or
yeah, I'm just in your group's opinion, would you say that the failure of the grid is due to lack of maintenance or due to asset management errors? Because if you have a good asset management system, you know when certain what is the life expectancy of certain things. So I think it's true that it's a lack of maintenance, but I think it's also a lack in asset management structure.
Most definitely a lack of management, because I think it's back in 2005 when they decided to adapt the reactive maintenance policy. They did not consider the long-term effects. So they have not looked at their asset management structure properly in the past however many years, and they have not realized their mess ups when it comes to reactive maintenance. So the power stations are failing because the maintenance procedures from the asset management procedures are in tatters. They shreds. Yeah. Okay.
I maybe also want to make a comment just on the one question regarding whether it is worth it to do condition-based maintenance or whatever on an old plant. The point is on the one side that you have the old plant, you have to do the best that you can with it. And the whole issue of whether a plant is old and needs to be replaced is a bit of a relative issue, because you can run an old plant at quite a good reliability if you maintain it very, very well. So it depends on how good your management of the asset is. And by that, I'm not saying, of course, there's a point where you say, well, it's now worth it. The point being that when I replace it with a new thing, then the cost of running over the long term will be lower for the new item than for the old item. I mean, that's really what it boils down to. And that cost includes cost of downtime, in other words, production losses. And it includes all types of maintenance costs and so forth. So it's a bit of a relative issue. The point with Eskom is that the plants have not been maintained well, and that is the main problem. The main problem is not that it's old. The main problem is that it has not been maintained well. That people did not do their job well enough.
Andries can help along with answering this.
Yeah, sure. Andries.
I agree with Prof, but I just want to make a comment about the causes of poor maintenance in the substations. As Matthew said, Eskom does not have a shortage of capacity. They have 45,000 megawatts of capacity, where the demand is only 30,000 megawatts. A study in 2019 showed that in 1 week after 8 generator units went down due to boiler tube leaks, 5,000 megawatts power were lost. And there's so much maintenance problems with Eskom. I'm actually referring to the question you asked for, is the maintenance worth it? And my personal opinion is that it isn't sustainable. Coal isn't really sustainable. The world is moving to a more sustainable way, and maybe Eskom has to look into a more cleaner way of energy production. But yeah, that's only my side.
Just can I just
Mr. Latergan.
Just a quick one. I 100% agree with you, Prof. If you look at Koeberg and you look at the rest of Eskom, Koeberg is well maintained, and you see breaker to breaker or shutdown to shutdown running of a plant, and because there's a very good maintenance strategy in place, and the plant is also old. So just a comment on your statement earlier.
Okay, Mr. Chagwedera.
Okay, it's Chagwedera. Right. I just wanted to understand. I think the previous speaker spoke about Koeberg and the other power stations. I think with Koeberg you've got the maintenance there, or the operations there are regulated. They are statutory maintenance and requirements that needs to be done there. So I think it will be very difficult to compare that Quebec, which is a nuclear power station, with the other power stations?
That's it's just a comment. Can I also add to that? The coal-fired power stations at ESCOM, if even if you guys have worked there, when it comes to doing the outages, certain stations and certain units within certain stations don't get the, let's say, what do you call it, the estimated required time to do the full inspection of the full power station. And therefore, in most cases, you find situations where, let's not call it cutting corners, but certain parts are not inspected and are not fully replaced due to the limited amount of time given for these large maintenance operations during an outage. So it does happen, and you wouldn't find the very same thing happening at a station like Coburg, because as my colleague here just stated, it's a nuclear power station and it's strongly regulated in terms of maintenance.
Okay. Okay, I think we're through with group 5 now. Oh yeah, group 5. I think we may need to look at group 4. So maybe if you can, I'm just changing Ms. Venter, making her representative again. Okay.
Hi, Prof.
Okay.
So I do have a backup of the slides, and then the same error still appears, but then I'm still going to continue with the presentation, if that's okay.
Yes, I saw that, and I think you now have to push through. It's just like it is.
Okay. Okay, thank you, Prof. Okay, good morning, everyone. My name is Vanessa Pena, and I'm presenting on behalf of Group 4. The focus of our slides are on failure principles and the renewal theory. As mentioned previously, this presentation is on Module 2 and 3, which is about failure principles and the renewal theory. Before we get started, let us first define what failure is. More particularly, what is functional failure? Functional failure is when an asset is unable to perform its intended function or several functions at a specific standard. There are many causes of failure in a component, machine, or system. Failures could be due to metallurgical-related failures, and this is split into stress-induced failures such as creep and fatigue, and environmental-related metallurgical failures such as corrosion. We know that rust weakens a material, which in turn affects its structural integrity. Another cause of failure would be due to design errors such as miscalculations made in the design stage of a machine. It is generally unsafe to create mechanical designs not adhering to design standards. An example would be the SAN standards, which are standards put in place for the performance requirements of a specific product. Poor installation is another cause of failure, and this is due to poor workmanship or no quality control performed while a machine or system was installed. Lastly, a machine can fail due to equipment mishandling. These are when operators of machines misuse the machine. An example of this would be operating a machine past its maximum rated load. In this slide, I was supposed to discuss the quantitative descriptions of failure for components. So the four most important descriptions of failure would be first the failure density function. And I will be walking through what we can do with the formulas and how we can apply it in the world of maintenance. So the first one would be failure density. It is a function that provides the probability of failure at a specific time t. So from this formula above, we can easily calculate the failure density, which is 1 over n, which is the original population, multiplied by the number of failures per time interval over a specific length of time. Second description would be cumulative failure distribution. It is simply the area beneath the failure density curve, and we are able to calculate this simply by taking the definite integral from the origin to a specific time t. The third description would be the survival function, which is a function that provides the probability of survival at t. We can easily calculate this by subtracting 1 from the failure distribution. Lastly, and the most important description of failure, would be the hazard rate, or the force of mortality. This function provides the risk of failure at t, and its shape can tell us which proper maintenance strategy to implement in the plant. and is simply calculated by dividing the failure density by the survival function. Now we move on to the renewal theory. The purpose of the renewal theory is to restore components back to an as good as new condition by analyzing its failure data. From the failure analysis, a proper maintenance strategy can be selected and implemented. The Weibull distribution was specifically developed for analyzing failure data, especially for practical applications. From the formula here, we can model the hazard rate for a component using the Weibull distribution. However, you can also use the Weibull distribution to model the cumulative failure distribution, the survival rate, and the failure density. I've included this curve here to demonstrate the effect of changing just the shape parameter beta. For a hazard rate curve, when beta is 0.5, we have an exponentially decreasing hazard rate. When we increase beta to 2, we have a linearly increasing hazard rate, and when beta is greater than 3, or in this case 4, the slope of the hazard rate is steep, and it increases exponentially over time. We will see how we can use the shape of the hazard rate to determine which maintenance strategy to implement. Now we move on to the maintenance tree. There are three main categories of maintenance, namely corrective maintenance, preventative maintenance, and lastly, the design out option. Corrective maintenance is the run to failure method. This is when no strategy is set in place to prevent failure from ever happening. Only when a machine or component fails, corrective action is taken to restore it. Examples of corrective maintenance are repairs, replacements, and delayed decision making. The second type of maintenance strategy is preventative maintenance, which is further grouped into condition-based, which means using monitoring software and instruments to measure and monitor parameters of a machine or system. Use-based maintenance generally refers to properly planned and scheduled maintenance activities. Lastly, the design-out option is when a component is redesigned or replaced in order to prevent the recurrence of a certain failure mode. The bathtub curve is shown here on the bottom. I'll be demonstrating how we can select a suitable maintenance strategy simply by analyzing the shape of this curve. The red curve here on the bottom is an increasing exponential hazard rate. This shape is produced when a component is placed in a high corrosive environment. It is also good to note that machines are generally designed to live up to a certain age. Once it operates past this age, a number of failures can occur until it completely breaks down. For this wear-out curve, use-based preventative maintenance must be applied. The green curve exponentially decreases over time. In the beginning, the hazard rate is high because failures are due to installation or manufacturing errors. Once these are fixed, the hazard rate decreases over time. For this curve, we apply condition-based preventative maintenance. Lastly, it is possible to have a horizontal hazard rate. This simply means that majority of failures are caused by random failures such as power trips and damage to small electronic units within a component. For this, we simply apply corrective maintenance. My last slide compares the pros and cons of the three main maintenance strategies. For corrective maintenance, we spend a minimal amount of time on planning and maintenance activities itself. It is a quick fix solution. However, for corrective maintenance, we require practitioners skilled in diagnosing and treating failure on the spot. In addition, maintenance and inventory costs are generally higher since the failure was not predicted. We now focus on the pros of preventative maintenance, and as mentioned, it is the planned and predictive approach. The advantage would be predicting failure, increased safety in the plant, and lowered overall maintenance costs. The disadvantage of this is that we are spending an extensive amount of time planning and executing maintenance activities. Lastly, we will talk about the design out option. The advantage of this is that we focus on eliminating a certain failure mode, and there is also room for improvement. However, the disadvantage of this method is that there is an extensive amount of time spent on changing and implementing the new machine and component. This concludes my presentation. Thank you.
Okay, any questions?
Just one question. My name is Njavulu. I just wanted to find out the different maintenance strategies are largely based from what you presented on the hazard rate curve. What happens when you don't have the data to decide on which maintenance strategy to use? What other alternatives can you use besides the curves to know which maintenance procedure should adopt in practical, like in real life situation, if you don't have data to construct that curve?
Okay, thank you for your question. So if you don't have the statistical models for or the failure data for an equipment, you can simply refer to other employees with their experiences with the assets of the company, which is what we covered in module 1, which is asset management. Or you can analyze all the types of assets you have in a company, and then you can refer back to the equipment manuals and see the behavior over time. So those are other ways in which you can analyze failure data besides looking at statistical models. So it can be based on experience from other workers, or can look at equipment manuals. Does that answer your question? Thank you.
Mr. Kiso.
I think just to add on to what Vanessa just said, that if you don't have data, I think lately most of our equipment are equipped with certain technologies depending on your environment. You can always contact the OEM to come and try and get data from whatever computer system that you have installed on the machine. I think it might tell you the condition or the operating system of that specific machine. And I again think that there's nothing wrong with starting putting things from scratch. You probably have the age of that specific equipment, but the history, if it's not there, you've got formulas. Just start putting. It's always good to start somewhere with whatever it is that you have.
And I would also like to add something. I did cover in my presentation condition-based preventative strategies. So as what she was saying, we can use softwares to monitor the activity of maintenance. So that is also another way in which we can analyze failure data without having the failure data itself by software. And yeah, because it can tell us the history of the maintenance activities in the plant, in a specific plant.
Okay, Ms. Kuane.
Good morning. Great presentation. I just want to ask: is it correct to actually refer to the reactive type of maintenance as corrective maintenance? That's why I'm asking, is because when you do even preventative maintenance, when you do say condition monitoring on an equipment, and then there's additional work that has to be done to correct whatever that you've identified, that is corrective maintenance, or at least that's how I'm understanding it. So is it correct to actually call that reactive maintenance corrective maintenance?
I think if I understand you, so what you want to know, is it correct to refer to corrective maintenance as reactive maintenance, or is it vice versa?
Yeah, because remember when we were talking about the different types of maintenance strategies, you actually said corrective maintenance, which you are referring that to as the reactive maintenance, because you're saying the run to failure. So I was saying, is it right to actually call it corrective maintenance? Because in my
Can I say something? I think I'm the guilty party there. I call breakdown maintenance corrective maintenance. But there is another way of thinking about the idea that you correct something is something that as you say, there's another definition of corrective maintenance, but I don't take that definition well. So I use the term corrective maintenance, and it's not only me. It's widely used in industry, the term corrective maintenance, for when a thing has failed. So, but yes, there in actual fact, that's not the only term that is disputed in the asset management world. There's more terms that are, and the big thing is that you must understand what you understand. You must understand it for your situation. You must understand it correctly. And you must also, when you read and you see that somebody uses a term, you must understand that that term might be used differently to what you think about that term. Mr. Nkuane?
Yeah, I hear what you're saying, Prof. So I just want to understand then that the example that I gave with the condition monitoring, if you identify
if you read my black book, which is the one that we're really working with here now, and you will see that the term is corrective maintenance for when the thing has failed.
Okay. All right. Thank you.
Ms. Kola? Mr. Kola?
Prof, I'm sorry, I just got confused by that statement because I was under the assumption that corrective maintenance is only done when, let's say, for instance, the output done by that particular asset does not meet the minimum requirements of that particular process. And reactive maintenance is only done when there is failure of an asset. Because that was my understanding. That's what because I don't know if I'm confused.
It's terms, and there is a confusion of terms. So you will see that when you read the black book, you will see that I never use the term corrective maintenance, but I do use the term corrective maintenance for the correcting of a failure.
Yes, yeah. So when there is,
it's two different uses of the same term.
Okay, so let me just clarify. So let me just try and understand. So corrective maintenance is when that particular asset is still functioning, but then the output that it gives out is not what is normally required by it. Well,
that's your definition. That's not my definition.
No, I'm asking.
My definition is corrective maintenance is when the thing has failed.
Okay.
Okay.
Prof, just to jump in there quickly, I think I understand where the questions are coming from because it's one of the discussion that was had in one of the classes. And it's something that we discussed as well during the group presentation, that there's a bit of a conflict between what we learned in another class and then this class. But when we do a presentation, we try to align with what has been taught from this class. So I understand where Mr. Kola and where Ms. Ngwane are coming from with their questions. But yeah, I respect it.
Good. Right, are we finished with group 4 then? Thank you, Ms. Pina.
Thank you, sir. Yes.
Okay, group 6 then.
Prof, I want to find out if it would be possible for me to do a screen share because the correct presentation that we want to do includes videos and it is not yet uploaded onto the file. So would it be possible for me to do a screen share with the presentation on my screen?
I'm sure it can be done. I don't think I have something bad against it. But I think what we like to do is we like to share this presentation with the rest of the students. So I put it on ClickUp so that it can be downloaded and can be used. So maybe if you can then I don't know what do you want to suggest then?
Well, it might be possible for me to then just email you the presentation that we have and then you can just upload it, or while we're still busy with the class later on, I'll try to upload it again.
Okay, that's fine. That's fine. But you can share your screen.
Okay. Is everyone seeing my screen?
Yes, we see.
Okay. Good day, everyone. Today, we as Group 6 will discuss the importance of proper maintenance. The objective of this presentation is to identify the causes of failure in lubricants, mechanical components, electrical components, steel structures, and concrete structures. We will also identify why a proper maintenance plan is essential for all equipment and systems. Lubricant failure can be caused by many different factors. The first factor is water. Water will promote corrosion of parts and filter plugging. Oxidation is the reaction between materials and oxygen. It can cause an increase in viscosity, acid numbers, corrosion, formation of varnish, sludge, and sediment. It will also cause additive depletion, base oil breakdown, filter plugging, and the loss of foam properties. Contamination is another factor that will cause degradation of lubricants. Improper labeling of stored lubricants can lead to the wrong lubricants being used. Human error is another factor that can cause lubricants to fail, as over or under lubrication can lead to an excess heat and damage the components. Chemical changes can occur in lubricants if other problems are already present, such as corrosion. When the operating temperature exceeds the thermal stability point of the lubrication will become unstable, causing the composition of the oil to change. This will lead to the lubricant being unable to perform its intended duty. This is the reason why proper maintenance should be done on lubricants, such as selecting the correct viscosity, oil analysis, regular monitoring of in-service lubricants, proper storing conditions of lubricants to keep it cool, dry, and clean. Proper maintenance might identify problems in lubricants before they become failures that will lead to unscheduled downtime. This downtime will lead to unplanned costs. Just hold on a second, please. I apologize for the delay.
No, it's fine. We know technical hiccups.
Okay, I'm sharing again. Is anyone seeing?
Not yet. Yes, there we see.
Okay, is everyone ready?
It depends on whether you're ready.
I'm ready. Okay. As in the case with the Viking Sky cruise ship, even a small maintenance error, such as the oil levels being in the lower ranges of the allowable oil levels, can lead to the unimaginable consequences. While this cruise ship was on a voyage, it cruised through a big storm, causing rough seas. The extreme listing of the ship caused the oil sensors to identify the oil levels as being too low, causing the engines to shut down to prevent damage to components. This led to the ship drifting without power, dangerously close to offshore rocks, and taking on water. In this instance, no lives were lost, but it could have been so much worse than just the cost of evacuation, rescue operations, and repairs of the ship. Engineering failures caused as a result of defects in the design, process, quality, or even application which ultimately leads to failure. A few common types of failure mechanisms are brittle or ductile failure, fatigue, creep, corrosion, wear, thermal shock, and impact. Each failure mechanism produces a different type of fracture surface, which as a result is an indication of the loading factor history, design geometry, and operating conditions of the components, which is of critical importance when failure analysis is performed. The establishment of maintenance schedules and the utilization of equipment monitoring tools are a few of many ways to mitigate premature failure in engineering equipment. It is important to monitor the propagation of cracks in material, the weakening of surface areas leading to cracks and distortion occurring at elevated temperatures and constant stress. As can be seen, due to overloading, components will fail, causing damage to the environment or components, or even causing the loss of lives. Almost all systems and machinery utilizes electricity as a power source. However, if proper maintenance is not done on the electrical circuits, it can lead to very expensive damages and can even be life-threatening. Causes of electrical failure due to poor maintenance plans includes loose connections, moisture buildup, power line disturbance, decay of insulation, short circuits, overloading, and accumulation of dirt. Loose connections will lead to a loss of contact pressure that can result in a highly resistant connection, leading to a current event, frying connectors, or even starting a fire. Moisture buildup can lead to corrosion of connections. This corrosion can cause short circuits that can damage your systems and machinery. When there is an unexpected fluctuation in frequency, amplitude of the voltage and current supplied to the components, we call it power line disturbance. The fluctuation can cause components to operate outside of their operating, leading to failure of the component or to undesired outputs. Over time, the environmental elements will wear on the insulation, causing it to decay. When insulation is not properly maintained, it will expose the wires inside to threats such as short-circuiting, corrosion of cables, and even the dangers of electrocuting a person. All electrical circuits have fail-safes in place to prevent lightning from damaging the circuits or components. These fail-safes include earthing wires and breakers, but these components can fail over time due to aging and neglect. If proper maintenance on these components are not done, the lightning will cause a huge flux of voltage into the system, leading to exceeded system limits. This can cause catastrophic failures, as can be seen in this video. The most common causes of failure in steel components include corrosion, cracks, overloading, overstretching, and human error during installation. It is important to do maintenance on steel structures as they are prone to corrosion. Corrosion can also occur at the connection points of steel structures where they are bolted together. Propagation of cracks in structures should be monitored during scheduled maintenance to ensure that the cracks does not exceed the allowable crack length. Overloading or overstretching steel components will cause the components to operate outside of their design conditions. Human error while installing steel components can lead to steel structures having unplanned bends and twists that can lead to failure. Common failure types include shear, flexural, compression, and tensile failure in steel structures. This video shows how steel structures can fail while operating outside of the design conditions. Concrete structural components can fail due to concrete and rebar corrosion, due to moisture and chloride ingress, impact, explosion or heat damage around the area of the concrete structure. Structural collapse or damage after storms or natural disaster. Settlement or collapse due to foundation failure and deflection of racking due to extraordinary loads. If there is a proper maintenance process and schedule in place, any corrosion, damage on the concrete structure, and a decrease in the integrity of the concrete structure will be identified before it leads to failure, as can be seen in this video. Even after the integrity of the bridge was questioned due to cracks in the concrete, a proper maintenance was not done and the bridge failed, causing the lives of 3 people. In conclusion, a proper maintenance plan is essential to prevent damage to surface, to prevent damage, to save lives, to prevent downtime, to maximize the availability, reliability, and operability, and to minimize unnecessary and unplanned costs. It will take longer to repair a failed component than it will take to maintain it. If damage is noted during maintenance, it should be set in motion to be corrected immediately, instead of waiting to correct it and ultimately causing it to fail before the corrections were done, possibly damaging the environment and equipment, or even causing the loss of lives. Thank you very much.
Thank you so much. Any questions? Ms. Pena.
Hello, I have a question regarding the failure modes. So if you're starting off as an engineer, as an EIT, say for instance, what would be the best way to learn all the causes of failure? Would it be from experience or reading theory? What do you think?
Starting with theory will be the best way to get a basis knowledge, but when you go further and you get the experience of different types of failures, it will be easier to evaluate that.
More questions? Or are you happy? Thank you, Ms. Pena says. Well done, great presentation. Okay, that I can't see. It says 7 new chat messages, so there's a lot of chat messages occurring here. I just want to see. Good presentation, great presentation. Well done. Thank you. She's on fire. Well, can you go and evaluate Group 6's presentation? And I don't know whether you did it for Group 4, so if you must maybe do Ms. Pena as well on Group 4, if you did not do it. So please do that. Ms. Venter, it seems as though everybody is very, very positive about the presentation of Group 6 and your presentation. Anybody for Group 7? I can't remember whether we had somebody for Group 7 to present. I think Group 7 was a bit of a problem.
The one guy had to go for work, the presenter, Vihan, I think it was.
Was he the presenter?
Well, he wanted to present, and then he said that he couldn't make it for Group 7.
But surely he could leave the presentation for somebody else to present.
I don't know what happened in Group 7, so that's just from what I read.
No, I saw that he had to go. That I saw, but whether that's a good enough excuse, you have seven people in Group 7. I think one of the 7 is new. The other 6 were there. So we don't have a presentation for Group 7. So we're then finished. So hopefully you've evaluated Group 1, Group 4, Group 5, and Group 6. No, Group 1, Group 3, 4, 5, and 6. In other words, 5 of the groups. on your evaluation. We can make a break if you want to have a break, or otherwise we can then go on with my slides. What do you suggest?
10 minutes break, please.
How much?
10 should be okay to make a coffee.
Okay. So let's make a quarter of an hour break. That's fine. Or do you need longer? 15 minutes, is that fine? Mr. Chan also says 15 minutes. So let's do 15 minutes. I see I have a problem with my share. I don't know. I think I have to restart. Maybe I don't know what I have to do. I'll try and do what I can because I don't see my slides anymore. So just so please go for a break. 15 minutes. So we say 11:30. Is that fine? What time is the lunch break? Well, the lunch break is normally 12. Now you keep the session open. You keep the session open. You don't go out of it. So I just have to get my share back.
Sir?
Yes.
Today I wanted to ask, what time are we having our lunch break today?
Lunch break is at 12. That's the formal
I
time.
see. Yeah, okay, no, it's fine. Because I see we're taking a 15-minute break. Then at 12 o'clock we're taking a lunch break.
Yeah, I think we've taken
Is that how
15 minutes. It might even be that we're finished by not long after 12.
Okay, no, it's fine. No, I was asking because, yeah, I need to go pick up my lunch at 12 off-site, but yeah.
Oh, okay. Off-site, how far is that? How long time?
It's a 2-minute walk.
Oh, it's a 2-minute walk.
Yes, sir.
Yeah. No, but that's fine. We will excuse you then if we go on there. But yeah, is that okay?
No, it's fine, sir.
But
Thank you very much.
Let's see. We now come back on 11:30, and then we will see what we do.
Okay, thank you, sir.
Okay.
Prof.
Yes.
Can I ask a question, just from my understanding and clarity? It's not really linked to the presentations, but I just have a curious question around when you look at something like, let's look at any component, any engineering component, and it has an expected useful life of 20 years. And for your maintenance strategies that you probably are utilizing preventative maintenance, you keep it running. And then it gets to a stage where you pass the 20 years, right? Now, before you get to 20 years, obviously you're going to start to employ strategies of predictive maintenance to start and condition-based monitoring. But I just want to ask, that predictability, that predictive maintenance and whatnot, once you pass your useful life, let's say by over maybe 30%. So let's say after 20 years, now you're close to 27 years of operating the instrument. Is it still applicable, the predictive techniques and predictive maintenance techniques you're applying? Do they still apply? Because I think once you pass your expected useful life, failures then become totally unpredictable now. Or am I just wrong with this one?
No, it never becomes totally unpredictable. You have to monitor, and you have to decide based on your monitoring what you what you do. Is it Mr. Zulu that's talking now?
Yes, Prof. Yes, Prof. That's me.
Can you just give me a moment? I have to go out of here and come back in. Can we continue our discussion when I come back in? I have to go out because my share does not work. So I must just so I just go out for a moment, and I.
Swangsena, are you there?
I am still there.
It's just, I don't know if it's possible that the conversation in Prof's absence, or did you want specifically his input or take?
I can feel engaged, man. It's an open platform.
Oh, okay.
Yeah.
Okay.
Okay, I'm back. I'm totally back.
Okay, we actually wanted to continue with the discussion, just so that maybe we could share our experiences or knowledge. But yeah, you can take over, Prof.
No, Mr. Zulu was busy.
Prof, I've given my question. I think Gloria wanted to also participate in the same topic.
Okay,
so,
no, fine.
Open. Glory.
Mr. Jana, you also want to say something? Terence.
Hello? Hello, Prof?
Yes.
Oh, can you talk?
Yes.
Oh, no. I was unlucky that now I missed the first session or the first presentation again. I just want to understand. I wanted to just get a feel on how far behind I am, and if I don't know if I'm right to say there was a test that was now also taken in the first class. I'm just trying to understand my chances of carrying on with the module.
Now, if you say that you say that you did not do the first class.
Yes, I missed the first class because
But the first class is on video on ClickUp.
Oh, okay. Yeah, I had a look at it, but I wanted to understand to say during that class, was there any tests that were taken or not really?
No. No, that was an introductory class. That was just to introduce the subject area.
Okay, all right. And then in terms of the rest of the module, is the idea that the test that we're writing now, they will build up into the final mark, or how does it work?
You know what?
Yeah.
You have to go on ClickUp and you have to go and read what it says on ClickUp. Everything is there.
Okay.
I can explain to you what I've done a lot of trouble of explaining to you in detail on ClickUp.
Yeah.
Everything there.
Yeah. Elon? Hello? Oh, okay. Hello?
Regarding the marks and how the marks work, the marks are it's quite a complicated way that in which the marks work because of the way in which the subject is presented. So you have to go and read on pickup. That's the only way to understand it.
Okay. No, I'll definitely give it a chance. I wanted just to get a sense on how far behind one is, and if there's still reasonable chances of success, if I can put it that way. But yeah, I'll certainly continue browsing the information on ClickUp.
Okay, Mr. Zulu.
Yes, Prof. Just with regards to how the marks work, not a detailed question, but it's around. So as a group, we can have a WhatsApp group, and we chat on the WhatsApp group about the course and stuff. But most of the time, as a group, we prefer interaction with one another. So we open a whole Google Meet meeting. Is that going to affect us? The overall marking when we send our export and it doesn't have as much detail in terms of discussions because we have it on a Google Meet platform.
Do you take a video of that?
Now we will. Sorry, now we will.
Oh. Yeah, well, whatever. I try to evaluate how good your interaction is and how well everybody participates and adds value and so on. So whatever way, I'm open to anything. And in the past, I've had different ways that people did it. So I do whatever comes my way. The WhatsApp group is just a very convenient way, but Google Meet is fine. If you take a video, if you send me something that I can do something with.
Thanks, Prof. All right.
Hey, Sbongiseni. Hello. So do you understand in your case on how the overall marks of everything now come together? Can you maybe send me your phone number? I mean, I just want to understand how the whole pass mark comes together. Do you mind if I have your phone number?
To whom are you talking now?
Oh, sorry, I was talking to Sbongiseni through the system, but I think I'll take his separate number offline, and then I think we can carry on with the discussion offline. Because I can see I'm gonna get you not so happy if I keep on asking this question.
No. I just want to understand what you're saying.
No, I think you've tried to answer my question to say I must go and catch up on the information on ClickUp. But I wanted from your discussion with Sbongiseni, I can see that you already understand the question that I'm trying to get to. Just want to get a sense or a feeling how far behind I am, if only yeah.
Mr. Isaacs.
Good morning, Prof. I just wanted to check. So this morning's test, is that towards the earmarks, or were you just trying to gauge our understanding?
Go and read on ClickUp. You will see what it is. Go and read on ClickUp. It's all there. It's all there. Right at the top of ClickUp, you'll find course information. Second from top. Course home, then course information. Everything is there. But of course it counts. Of course it counts.
Okay. Thank
Very
you.
important part of the course. Okay, so we're at 11:30, so I think we can maybe start slowly. Let me give it a few more minutes, so as to make sure that everybody is here. Right, shall we go? The modules for class day 3. The modules for class day 3. Now you have it on ClickUp, so it's if I say class day 3, it's now called class day 2 here. In other words, it's the next class cycle. So these class days are more like class cycles. So it is class day 2. We will do module 5 on strategic principles. Module 6 on replacement decision making, using the information that we built up in modules 2 and 3, using that and going further with that replacement decision making. In actual fact, our workshop will be on that. And then module 7 on reliability-centered maintenance principles, RCM principles. And then module 8 on maintenance and failure risk. So that is what we have for the next cycle. And what I said is that we will slowly but surely release the information on these 8 modules. So we'll talk about that again when we finish the class. Any questions here? Okay, so then we go to introduction to module 6, replacement. And that is really all that is left for the class for today, apart from the workshop. And the workshop you will be doing over the rest of the week, together with the assignment, with the assignment 1, which you're still busy with. Now, we've had a discussion like this, so I'm now one of your groups talked about these various shapes of the hazard curve, and you will see that we refer here to RCM Proactive, the black book, figure 3.8 and table 3.1, which is on pages 70 and 71. And we will be talking about this. Let me just see something. I must get to my notes as well. Just a moment. I've now forgot about that. Just have to page on until I get there. Yeah, right. Okay, so in module 2, you encountered the force of mortality or hazard function in the book on the figure and table as is listed here on the slide. There's two names for the hazard function or the force of mortality function. It is called the momentary failure rate or the conditional failure rate. It is the failure rate at the specific time, given that failure has not taken place up to that time. So it's a conditional. That's why the term conditional failure rate is a very apt condition. So it is conditional on the fact that failure has not yet taken place up to that time. So it is that then the rate at which failure takes place, given that it has not taken place. So it essentially gives the risk of failure of the component at that specific time. So that's really what it does. It gives you a value to the risk of failure. Right. So if we go on this topic, we go to the next slide. It's the same. It looks exactly the same. I have different slides simply because I have for my notes. So the first graph in the diagram shows an increasing force of mortality, that left-hand side one, indicating what is called a wear-out failure pattern. Now you will see on the table that it is described that typical failure mechanisms that causes such a failure pattern includes erosion and corrosion and chemical attack. We also mentioned fatigue in the previous slide. It includes any grading failure mechanism. So those are just three examples: erosion, corrosion, and chemical attack. So it includes any degrading failure mechanisms which causes the risk to get higher, the risk of failure to get higher as the component ages. So that's really what wear out entails. So it's not just wear, but it's much wider than that. Typical components that experiences what is called a wear out failure pattern includes ground engaging tools. So if you go to a mine and you have a big excavator digging into the ground, those ground engaging tools, they tend to experience such a failure pattern. So we say such as the tip of an excavator bucket, the liners of a chute for transporting highly abrasive materials, a car battery, car tire. All of that is wear out failure patterns. All of that displays failure, wear out failure patterns. If we look at the second graph, maintenance strategies considered for component subject. Oh no, I'm still on the wear out. I'm sorry. Maintenance strategies considered for components subject to wear out So there you have a list of some components, and then you have the type of maintenance which refers there to failure figure 2.2. The first one that you can consider for that is condition-based maintenance. Typically, the component is inspected, and the maintenance action is based on such inspection. For example, a chute liner is worn thin. So when you inspect, you see it's worn thin, leading to the replacement of the liner. Second type of maintenance that you can consider for that is use-based maintenance. Based on historic data, it is known that the component needs to be replaced based on its use. For example, the brake pads of a car is prescribed to be replaced at 60,000 kilometers for that specific car. That would be a use-based strategy. But that does not say that you cannot inspect the brake pads at a regular basis and maybe even replace it sooner than the 60,000, or go past the 60,000 if you see that it has not worn that much. So the fact is that you can use condition-based inspection or strategy, or you can use a use-based strategy. The third one that we list there is corrective. For some components, the maintenance action is delayed until after failure. An example would be a car battery. It is typically replaced when it becomes clear that it cannot provide the required power. In other words, you just see that you cannot start the car a morning, or you hear that it's turning over the engine slowly, and you then have it replaced. Then it's basically failed, and then you replace it. And our discussion that we had before, you understand that my idea of corrective maintenance means that the thing has failed, and you then replace it. Design out. Some critical components cannot be allowed to fail, and thus the failure mode needs to be removed or designed out. An example might be a critical bearing that is greased manually, but the lubrication is not sufficient. In such cases, sealed oil lubrication bearing might be designed to solve the problem. Designed or purchased if such is available, whatever. So that's a typical design out. If we look, second graph shows a constant force of mortality indicating a random shock failure pattern. The risk of failure does not change with age, but failure takes place when the component is subjected to some external shock. And there we make a list of the failure modes, the mechanisms. Failure mechanisms that may cause such shocks include electric spikes, such as lightning or other spurious discharges. Sudden overloads, that's the second one that we list there. And abuse can also cause this mechanism to occur. Typical components displaying such behavior, secondly, is listed there, include electronic components, plant tripping patterns, the tearing of conveyor belts, and damage caused by weather patterns. In other words, it's something that can occur anytime based on whatever the event is that happens. It's not you cannot predict it by the way in which the component is busy changing. So an electronic component, for instance, does not change with time. And I must just say that there might be a limit to the life of such a component. But normally, under normal circumstances, that component will not fail unless something happens to it, unless it has some shock. What did we call it? electric spike or whatever. And then thirdly, the maintenance strategies that we can consider for that is, again, condition-based maintenance. Inspecting, for instance, inspecting electronic boards for damage or dirt that may cause shorts. That's a condition-based inspection. Or you can also wait until it's failed and then replace it, corrective maintenance. And you can also use design out maintenance under the right circumstances. So it depends on exactly what is it that you have, whether you use the one or the other. And then lastly, the last graph that we have there is a decreasing force of mortality, which indicates a run-in, what we call a run-in failure pattern. And it's called a run-in failure pattern because if you have mechanical components that are new, you find that their possibility of failure is higher when it's brand new, when you have rough surfaces and so on. And then it improves. And because of that, it is called a run-in failure pattern. It's maybe not such a good name, but that is the name for it. The risk of failure decreases as the component ages due to some important failure effect parameter causing a decrease in the probability of failure. The failure mechanisms include quality defects that causes failure when the unit is still very new. Later in life, these defects are eliminated. The honing-in effect of mechanical components, such as a car's engine after reconditioning, and errors due to bad workmanship showing up early in the life cycle after repair. So that's typical mechanisms. Typical components or items that display such a behavior includes unit warranties, software bugs, equipment after major work, such as rebuilds, and newly machined surfaces bedding in during use. So those are good examples of items that display such behavior. And then the maintenance strategies, again, involved condition-based, corrective, and design-out strategies. Okay, so there you have it. There you have it. So that is what we have. Let's get to our next slide here. I just get to my notes there. In the case of an increasing force of mortality, that is when the risk of failure increases as the unit ages. It makes sense to replace or reconditioning the unit at some age, such as the age of 1500 hours on the graph. This will ensure that the risk does not progress above the probability of 0.002. So in other words, that probability there. In other words, the risk that failure will occur is at a level of 0.2% at exactly 1500 hours. And then you replace the unit. In other words, you cut off this part of the graph and you replace it by a new unit that starts at the bottom again. So your risk, you limit your risk between 0.2% by such a strategy. In such a case, use-based maintenance is based on this premise. In other words, on this principle. If we could numerically evaluate the cost of replacement versus the cost of failure to identify the exact point at which such use-based replacement should occur, we will win the jackpot. And that is what we're going to talk about. That is what we're going to talk about. We're going to attempt just this. Just a side note here, reconditioning the unit instead of replacing it can lead to the same result, although the age at which it should occur will differ. In other words, when you decide what this age must be, you determine, you take money figures to see what this risk in terms of percentage means for you. In other words, should it be 0.002 or should it be 0.003 or wherever should this take place? And that depends on the difference in cost involved. In other words, when failure takes place, what is the cost of the unit then? And if you replace it preventively, what is the cost then? Now, if you replace it with a new one, you get one possibility. But when you recondition the unit, then the cost of reconditioning will certainly be lower than that of replacing the unit. And because of that, you will possibly find, let's say this 1500 hours was for replacing it with a new unit, you will possibly find that when you recondition it, you can only recondition it at 2500 hours, let's say, and get an economic answer. So that's the idea. Okay, so let us go on. Now again, and in each case, even with the previous slide, you will see that it refers there to the specific figure in RCM Proactive in that book. So we're working with that book. We're working with that book in this case. So there we have figure 5.4 on page 106. We have here. So we say when we install a new component using use-based preventive maintenance, there are two possibilities. And these two possibilities are shown in this diagram. The first possibility is that a preventive cycle results after the use-based replacement. In other words, we have a preventive cycle. Now let's just look at that case. So there is the preventive cycle shown to us. I just want to get to my notes. So what we do is we install a new component. Here we have a new component, and we replace it preventively at the age which was determined for use-based replacement, which is TP. In other words, we will calculate that based on the realities that we had on that slide before. Let me just go back there. I want to explain myself well. In other words, in some other way, we will discover what this age is, which is the most economical answer. And what we're saying here is we're saying that that answer would be TP, that small little TP. So we either replace it there, and the time that it then takes to effect the replacement, that preventive replacement, is called capital TP. Okay, so that is the process that we then follow. But we also have another option, another possibility, and the other possibility is that a corrective cycle results after the use-based prevention. Because it's never sure that it will be a preventive cycle. It can be a corrective cycle as well. So sometimes you will find that when you fitted a new component, it does not last up to TP, but it fails at some age TC. You see, TC for T corrective. If you look at the maintenance book, in the maintenance book you will find that this is called TF for T failure. So the C's are called F's there. But for good reasons, I've opted to go for TC here because when we get to the second theory is called repairable systems theory. We're talking here more of components. So when we get to the systems, we again have a TF. And there was a confusion between the TF for components and the TF for systems. And because of that, I opted for TC here for components and TF for systems. We will later on get there. So corrective cycle means that it does not run up to TP. It fails earlier at a certain life TC, and it then takes capital TC to replace it. Okay, so yeah, I make the note that TC equals TF and TC equals TF in the blue book, the maintenance book, the white and blue book. You will find that it is called TF and TF. Okay, so just don't let that confuse you. Right, so let's go for the next slide, cost and profit models. So now both these scenarios are possible. In other words, you can have a preventive cycle or you can have a corrective cycle. And both will occur based on the probabilities inherent to the situation. In other words, sometimes you will get that a thing will fail before it gets to TP, before it gets to preventive replacement. Because failures take place from 0 up to all ages, so there's always a probability that failure will occur before you get to your preventive age. And we will discuss that further and it will become more clear. You have in the past cycle learned how to past class cycle. In other words, cycle 1 where the videos and the material that you studied. You have in this past cycle learned how to successfully fit a viable distribution to failure data. Thus, you are now able to decide whether use-based preventive maintenance is an option at all based on the shape of the hazard function. But you still do not know whether the use of such a strategy is worthwhile. So let us now denote the cost of preventive replacement as CP. Now, so that's the cost when you do a preventive replacement. That's what it costs you. The cost of correction CC, in other words, when you correct a failure, when you do the repair during corrective circumstances. Then first of all, for it to be worthwhile, the cost of correction must be higher than that of preventive action. I think that makes plain sense, that CP must be less than CC. Secondly, the total cost of the chosen strategy must be the minimum possible, given the probabilities involved. And now we're on page 103 here. The two cost quantities can be calculated from CC is the cost of spare parts for failure repair, plus the cost of labor for failure repair, plus the value of lost production while doing failure repair. I think that's fairly logical. So it's the parts, it's the labor, and it's the money that you lose in production. CP is then the same, but under preventive circumstances. Cost of spare parts for preventive action plus the cost of labor for preventive and plus the value of lost production while taking preventive action. And now we're on page 104 of the Black Book. Now let's go further. And now we're no, I've now slipped something. No, I've now slipped something, I think so. Oh yes, there's another slide in between. When dealing with failure modes with non-operational consequences, the downtime does not have a negative effect. In other words, you lose that one term. So CC then becomes just the cost of parts plus the cost of labor. And CP similarly, spare parts and labor. So that's all that's then left. Taking into account the discussion in the previous two paragraphs, the total replacement cost per cycle is then, we said that sometimes you will have a preventive cycle and sometimes you will have a corrective cycle. So what you now have is you say, well, yes, sometimes it will cost me CP, which is the cost of a preventive cycle, and sometimes it will cost me CC, which is the cost of a corrective cycle. And then we say, okay, but what is the cost? In what percentage of cases will a corrective cycle take place? You remember that we have a small ft, which is the density function ft, and then we have the capital Ft, which is the cumulative distribution function. Now ftp is the same as 1 minus rtp. So this, in actual fact, you could write as FTP. So in other words, the cumulative distribution function gives you the cumulative percentage of failures that will take place before or at that time. And that is then your probability of CC occurring. And the opposite of that is that percentage that survives up to that time is then the percentage of times that you will get CP. And that is then what we have here. So the total cost per cycle is given by this formula 5.1. Okay, and that's on page 107. Still on page 107, the cost per unit time or other measure then equals this. I just want to see. No, I skipped one now again. Sorry. That's a mistake. We were on that slide. We had the cost, TT, and here we have the length of a cycle. Expected cycle length that's the average life expectancy per unit. Is again, we have in one case, the preventive cycle will be small little TP plus capital TP. So that's the length of a preventive cycle. The length of a corrective cycle is TC plus capital TC. That's that there. And the percentage of cases for which this will occur is given by the survival function. And the percentage of cases in which this will take place is given by the cumulative distribution function. So there you have it. So that's the average cycle length, the expected cycle length. The cost per unit time then is then the one divided by the other one. CT on the slide, second past, divided by LE on the slide just past. So that gives us the cost per unit time. So it can be time, of course, it can also be other units of measure that we use to measure, such as the tonnage produced or the units produced or whatever. I must just not make that mistake again. Now, one thing that we sit with here that is a bit of a problem is what is the length of that TC? Because that TC can be anything from 0 up to TP, up to this TP. In other words, when the unit's time life comes to TP, you replace it preventively. But any time between new and that preventive replacement time, the thing can fail. So TC is a varying figure. But what we can do is we can calculate the expected value of TC. We can calculate from here. And we refer back to equations 422 and 426, which is the expected life, which you covered in the previous cycle. It follows that TC equals this quantity here. So you can go and have a look in chapter 4 for that. And if you now replace TC by this quantity here, you get this. And of course, just multiply by whatever is necessary. You just see again. You see this thing here is over 1 minus RTP. So if you multiply at the top of the equation and at the bottom by 1 minus RTP, you lose that term. And this is the end result. This is the end result. So so this is then the cost per unit time is then given by this. So now you sit with an integral here in the equation. And so what we do with that integral is we make use of numerical integration to evaluate that term. So we work with numerical integration. So the result that we get from that model is this. You see here, what we have here is we eventually sit with a curve that is has a very specific minimum, which is called CTP star, at a certain life TP star. And that is the time at we would like to practice prevention. In other words, we want to run at the lowest cost possibly. So how does this thing work? This whole curve is made up of two curves. This curve here is the preventive cost. And this curve here is the failure cost. So what we're saying is, if we do not prevent, or if we go for too high a life, the failure cost will become very high. In other words, failure cost, if we replace the unit every 0 time units, of course your failure cost will be 0. But the longer we wait between failures, the higher the cost of failure becomes. On the other hand, the cost of prevention, if we prevent very often, the cost of prevention is very high. If we prevent very seldom, the cost of prevention is low. So what we have here is this curve here, this cost of failure is given by, in this term here, in this formula here, it is given by CC 1 minus RTP, that term there, over all of this. That is that curve, the failure cost curve. The preventive cost curve is given by CP RTP over this whole lot. So you see, and we add the two together to get the total graph. Okay. The output from these models is a graph of the cost per unit time against the time between preventive actions. So there you have it, with the failure graph and the preventive graph just removed out of the picture. So we would like to practice TP star. Every TP star we want to replace the unit at the lowest cost CTP star. And what now happens is when you come to that live TP star, then you say, well, must I really replace this thing? This thing is still running, it's still working. And that's true. That's true. But the point is that on the previous graph, on the previous picture, we go back to the previous slide. It is true, I can now come here and the thing is still running. But on average, for my whole for this type of component, if I go past here, then on average I will find that my failure cost gets very high and I will be on the upward curve here. So when I get to TP star, I simply replace the thing. And I replace it, of course, if it fails before then. So that is the strategy that you then have. That's your use-based strategy. Okay, so what we now want to do is we want to look at how do we do it in a computerized way. How do we do the calculation, computerized analysis? So we say that, I must just check whether I don't have notes here. Just want to check my notes. I don't think I have much notes here. I had notes in the early part of the slideshow. No, I'm okay now. So for computerized analysis, we say that the analysis performed to fit a viable distribution to failure data, as well as the profit or cost modeling of this section, requires the computational power of a personal computer. So the first thing that we need to do is we need to know that we can numerically integrate. Okay, so that is explained in the book on page 80. So what that says is if I want to calculate the value of this, I need to take, if I say from minus infinity to TP or some h TP, and minus infinity in practice, you will work from 0. So what you do is you take your curve. This is now the density curve. We take, and of course that is the density function, the FT. So we take this curve and we break it up into small little chunks dt wide. So that's dt there. And we calculate t times ft, which is the center value there, times dt, and we say that is then for this little block here, that is that value tft dt. And so we do for various intervals here, and we then eventually add them together, and that gives us an integral. In other words, integration is an adding function. It's a mathematical adding function, and if dt is infinitely small, then you have exactly the area under this curve, and that's what we do. So now we come, and the way in which we do it is, this is the spreadsheet calculation scheme. So we now sit in the spreadsheet, you sit with columns, TP, FTP, TFTDP, the sum, RTP, and CTP. So that is the scheme. So what we sit here with is we sit with TP equals TP start, And we decide on how wide DTP must be. Remember now the previous slide, the DT there. So TP2, the second one, is TP1, that one, plus DTP. TP3, you add another DTP. And TP4, you add another DTP, and so you go on. For each of these TPs that you have here, you then calculate what is the density function value for that value of TP. And then you go and you start with the numerical integration like we had on the previous slide, TFTP-DP. In other words, what is that? It is T, there's T. FTP, there you have that. And DTP is the width that you worked with here. So you calculate that. And in this one, you just add up the various values in this column here to get the cumulative. And that is the integral. RTP, you can calculate directly from formulas like you did with FTP. You have that. And now what you now have in this formula here, you now have everything. You have TP. That TP is a constant which is given to you in any problem that you might have, or in practice, that is what you know how long it takes to do corrective action. You know how long it takes to do preventive action. So all you do here is you work with that TP. Or let's start at the top. So for that CTP, we know what CP is. That's a calculation that we did. We know what CC is. We know what RTP is because that's what we have in that column, and that so the top of that we can calculate for this, and the bottom we can calculate because we have TP. That TP is a fixed number that we have. RTP we do have, and let's just forget that one for the moment. Plus TC is a fixed number that we have times 1 minus RTP. We do have. And then that integral value is exactly what is in that column there. So we can calculate CTP for oh, now Siri is starting to try and tell me what I must do. I don't know why that happens. Okay, I've got it passed. Sorry for that, lady. So that is what we then do. Now, there's your problem for the workshop. Spreadsheet calculation. It was found that the viable distribution fits a certain gearbox's failure data set. In other words, the fit has already been done. That you've done in the previous cycle. So that distribution fits a certain gearbox's failure data set. The management of the company is concerned regarding the high cost of downtime attributed to failures of gearboxes of this kind. The parameters of the distribution are beta equals 2.35, eta equals 5560 hours. The following data is also available. The cost of the component is 18,000 Rand. In other words, that's what the thing costs, the gearbox, the gearbox. The cost of an artisan is 500 Rand per hour. When the component fails, a production loss of 26,000 Rand per hour is incurred. Preventive action is taken during an existing maintenance shift. In other words, there's no production loss during preventive action. The time used for a preventive replacement is 2 hours, and that of a failure replacement 8 hours. In both cases, 1 artisan. The preparation cost for a preventive task is 1,000 Rand. So there's an extra cost involved there. Determine the optimal preventive replacement life of the component by taking the replacement times into account. Use a time interval of 10 hours for the numerical integration. Now that 10 hours is then DT, DT. It's 10 hours. With then using the scheme that we just looked at. In other words, this DTP, that DTP there is now 10 hours. That little DTP, that's 10 hours in this calculation. So what I want you to do is I want you to go and do this in your groups and present me with one answer per group by Monday next week. So that's what you need to do. So you go and you talk to one another over the internet, over WhatsApp or whatever you're using, or one of the groups said they use Google, what is it, Google whatever, or Skype or Zoom or whatever you use. You can talk to one another and you can have a meeting and you can do this thing together and solve this problem. Create for yourself a spreadsheet that will do this and submit that for marks for the group by next Monday. So that's what I want you to do, because a workshop here now is not very practical, and because of that I sort of create this workshop for you that you do over the remainder of this week. Mr. van der Merwe, you want to say something?
Yes, Prof. I actually want to ask, the workshop, is it only one submission per group, or should each individual member submit?
No, this is one per group. This is one per group.
Okay, thank you, Prof.
Yeah. So I do hope that everybody will participate in it in a group, because what you can find, that's the negative about group work. That's, you know, some of you asked me for the assignments, whether the assignments are group assignments. We've tried group assignments before in this subject itself. I mean, I've tried group assignments in many situations before, and it has never worked. So even for a group workshop like this, it can be that one guy in the group does the solution and everybody just agrees and it is handed in as the groups work. But the problem is that if you're 7 members in the group and one member does the solution, then the other 6 do not know how that solution works. They may think that they know how, but they don't know how. So the big thing is to try and do this thing in a group sense, in the sense that everybody knows what is going on. So that's the trick. But what I then need is, yes, Monday, specific time on Monday. No, there's no specific time on Monday. I want it by Monday. Monday is Monday up to 1 minute before 12 o'clock Monday night. That is Monday. Okay, Mr. Hong says thank you, Prof. Are you guys happy? Oh yes, this whole not my whole slides, but the slides regarding what we did just now is on ClickUp. I think I already loaded it up there, and I think it is available. Let me just see. I just want to see classwork content area. Yeah, this thing can bother me very much. Yeah, I think you see on class organization. Class organization. There is class day 2 slides. It's not seeable for you now, but I'm showing you it now. I'm showing it now, so it will now be there. if you just refresh that page, you will see it under class organization. Class organization, just under the plagiarism declaration form. Class day 2 slides. Okay. All right, and then I think we're finished. Then we can break here, apart from those that will still want to write the test, that had a problem with writing the test and still want to write the test.